In this tutorial, you will build the coolest portfolio website ever. Not only because this website looks good, is fast and has a nice dark theme and is built with Next.js, but this website also has an AI chatbot. This chatbot is based on ChatGPT and it knows about all the information on this website. And for this, it doesn't matter how many pages we have and how much data, it will always find the relevant information on the website. So for example, I can ask it, "Who are you?" And after a short moment, it will reply. And as you can see, we also implement response streaming, where every letter streams in as it is generated, just like it works on the ChatGPT web interface. So it told me I'm the owner of this portfolio website. It also provides a link to the corresponding page, which is this About Me page. And we can also ask follow-up questions. I asked for the name because it didn't give me the name in the first answer. My name is Florian Walter, so it impersonates me. Let's try a different question. Let's see what kind of information we have here. For example, I have listed different social media accounts on my website. Let's ask it, "Do you have TikTok?" ? And it answers, "Yes, I have a TikTok account." You can find it here. It provides a link to the actual TikTok account. This is my Coding and Flow account. And it got this information from this social page on the website. Here is the TikTok link, and it found this link. And these large language models like ChatGPT are also smart enough to work with follow-up questions. For example, we can ask, "Can I get a shout out there?" Or maybe, "Can I buy a shout out there?" Because somewhere here on my website, I also talk about business inquiries. So down here, I talk about how they can get a shout out for their product. They have to contact me at my email address. So again, the bot should find this information on the website and give the appropriate answer. And it does. Isn't this cool? And it realized that this question still belonged to this first question here. Now what's even cooler, we also cache these responses. So if I clear the chat and ask the same questions again. So, "Do you have a TikTok account?" ? This time we should not see the response streaming in, because now we get it from the cache instead of from ChatGPT. This means we save money because these requests to ChatGPT cost a little bit of money. They are very cheap, but they can add up if you send a lot of requests to ChatGPT. But I think I asked, "Do you have TikTok?" right? Not, "Do you have a TikTok account?" So let's try the same question again. And this time the response comes immediately because again, this is now pulled from the cache and not from ChatGPT. And we can even ask the same follow-up question, and again, this should come from the cache. And there it is, without streaming. Now in this tutorial, we built a portfolio website, but this is also very suited for a documentation page, for example. In the future, you will see more and more documentation pages that have such a chatbot that can answer questions based on the content of the website, based on the documentation itself. This is super helpful. Some websites already have this. And as I mentioned before, this will work the same no matter how many pages we have or how large our pages are, how much information we have on them. The chatbot will always find the relevant pieces of information no matter how deeply nested they are inside the content. To build this website, we will use Next.js 14, we will use the OpenAI ChatGPT API, we will also use Langchain, and you will learn about important techniques like vector embeddings. Those are some of the most important skills you can learn right now because LLMs are everywhere. And I think in the future, almost every website will have such a chatbot, and they will be built with tools like Langchain. So it's good to learn these skills now because you will probably need them in the future and they will open a lot of job opportunities. Now, if you don't know what Langchain is or what you need it for, you will learn all of this in this tutorial. I also have another AI chatbot tutorial, which I released about 2 months ago. In this tutorial, we built an AI note-taking app where we also make a request to the OpenAI ChatGPT API, and we also use vector embeddings there. The difference is that in the other tutorial, we don't use Langchain. The other tutorial is simpler. This project here is a bit more complex than the other one. You don't have to watch the other one first, you can just start with this one directly. But if you want to watch both, then I recommend that you watch my other AI tutorial first. I will put a link to it somewhere here into the right corner of this video. The only prerequisite for this tutorial is that you know the basics of Next.js 14. I will link my Next.js beginner tutorial in the top right corner as well. I made this tutorial in Next.js 13, but it's almost the same as 14, so it still works the same. If you have never worked with Next.js before, watch this other tutorial first and then come back to this one. Alright, and then I wish you a lot of fun with this tutorial. Happy coding. So, first of all, we have to check that we have at least Node 18 installed. So open the command line on Windows, that's PowerShell, and type in node -v. This should show at least version 18 or higher. If it doesn't, update your Node.js version. You can find it on nodejs.org. Download the latest LTS version. But some of the stuff we use in this tutorial doesn't work below Node.js 18, so you need at least 18. Then, as usual, I will provide a link to the starting code for this project on GitHub. The link will be in the video description below. You can clone the starting code. The benefit of this is that you will have the exact same package versions as I'm using in this tutorial. This way we can make sure that everything still works the same, because when these packages get updates, sometimes the functionality changes and things break. But by downloading my starting code, you have the exact same version numbers. However, I will also show you how to set up this project manually if you are brave enough. Then you will have the latest version of each package, which also means that things might be different. In this case, you have to look into the documentation of the package and see how things are done now. But again, you can avoid this by cloning the starting repository from the link in the description. The only thing you have to do is you have to open this project and run npm-i or npm install in the command line to install all the packages. Okay. Now I will show you how to set up the project manually if you don't wanna download the starting code. Open the folder where you wanna create your new Next.js project, and here we wanna open the command line. On Windows we can do this by holding Shift down and right clicking and then open the PowerShell window here. Then as usual we create a new Next.js app with npx create -next -app add latest. We type this in and run this. We confirm this with Y. We have to give our project a name. For example, Next.js Langchain portfolio. The name is up to you. Would you like to use TypeScript? Yes. ESLint as well. Tailwind CSS 2. We also want to have this src directory, which is just there for organization. We also want to use the app router, so we confirm this with yes as well. Custom import alias, we don't need this. And then we wait until this project is created. Okay, then we can close the command line and open this project in VS Code. Next.js Langchain portfolio, there it is. Right click, open in code. Yeah, and this is a fresh new Next.js project. Then we open the terminal and install a bunch of packages. But again, if you downloaded the starting code, then this is not necessary. Okay, now we type out each package one by one, and it's important that you don't make any typos because yeah, these packages have an exact name. The first one is OpenAI in all lowercase. That's the Node.js package of the official ChatGPT API. Then we want Langchain, again in our lowercase, space, add Langchain / OpenAI, which are OpenAI helper packages for Langchain. Then the next one is just AI, that's the Vercel AI SDK. This is a really cool package by Vercel, the creators of Next.js, which make it easy to implement this AI chat into our Next.js app and also implement response streaming as you saw earlier. Then we need a few helper packages, CLSX, which is just useful to work with Tailwind classes later, Tailwind -merge as well, tsnode to run a TypeScript script. We also need .env, you will see how to use this later. Then lucid -react, which is an icon package. Next, themes to implement dark theme. React markdown, because the AI chat messages will be formatted in markdown. This way we can put links and stuff like this in there. And then we need two packages for two databases. The first is the vector database. This is how we later find the relevant pieces of information on our website. For this we install add datastacks / astra -db -ts. And for caching we will use Upstash Redis. So add Upstash / Redis. We confirm this with enter to install all these packages. This can take a minute or two depending on what potato you're running this on. But when this is finished, we should see all these new packages listed in the package.json here in this dependencies block. We also have to install a bunch of dev dependencies which are only used in development, so we have to install them separately. So again in the command line we type npmi, but this time we also type minus and in uppercase D after it. This is short for save dev, and this way we install dependencies only in dev mode. Here we need Prettier, which is a code formatter. It's really useful, especially together with Tailwind CSS, because it can order the classes for us. For this we need another package called Prettier -plugin -Tailwind CSS, and one more, eslint -config -Prettier. And these are all the dev dependencies we need. So we install them as well. Okay, then we go into our package.json and we scroll down. Now these different Langchain packages that we use, like the core package and Langchain OpenAI, use another package called Langchain core under the hood. Now the Langchain documentation recommends to set a fixed version for Langchain core to make sure that these different Langchain packages all use the same version. And the way this works is we go down below the dev dependencies block, we add a comma, and here we add this overrides field, which adds a block of curly braces. And here we write in quotation marks, add Langchain /core, colon, and then again in quotation marks the version number. Then we need the current version of Langchain core. If you did not download the starting code, then you can go to npmjs.com, and here we type in again add Langchain /core, and here we want to see what the current version is, 0.1.20. So we add this here, 0.1.20. Again, in the starting code, this package.json is already finished. But if you edit this yourself, then you have to save the changes to the file. And then I think we have to run npm install again to apply this change we just made. Just to be sure, run npmi. And then we have all the packages we need. Next, I also want to set up your IDE properly for Tailwind CSS and Prettier to make working with our code as comfortable as possible. Those are steps you have to do yourself even if you downloaded the starting code, because those are settings in your IDE that we have to change. First of all, we go to the extensions, and I recommend that you install this official Tailwind CSS IntelliSense extension, because this way we get autocomplete for Tailwind classes, which is extremely useful. I would even say that working without this is probably a nightmare. So install this extension. Then we have to change a few settings to make this work properly. So we go into the settings of VS Code. Here we search for file associations. Here you want to add a new item with these values, star.css and Tailwind CSS for the value. This way we make Tailwind CSS available in CSS files. This just makes configuration easier. Next we search for a different setting called quick suggestions. This one is particularly important. Here you want to turn on quick suggestions inside strings, because Tailwind classes are strings, and this way we get this automatic auto-completion when we type out Tailwind classes. Okay, these changes will make working with Tailwind CSS much easier. And as I said earlier, the Prettier code formatter we installed can automatically order Tailwind classes for us, which is really useful. For this, we already installed this Prettier plugin Tailwind CSS a minute ago. To activate this, we need this piece of code. You can also type this out by hand. And then we have to create such a Prettier config.js file in our project. So we go to the root folder of our project, create a new file called prettier.config.js. This is not inside another folder. This is directly in the root. And here we put in this piece of code. Again, you can pause the video and just type this out by hand. Don't be so lazy. And a few more settings. We open this eslint.rc.json file, which should be there by default in a new Next.js project. We change this value to an array. And then we add a second string here, just called Prettier. This makes sure that ESLint works properly together with Prettier and they don't clash with each other. This is described in the Next.js documentation. Okay, we are almost done with our setup. Next, I recommend that you also install the official Prettier extension for VS Code, because this way you don't have to execute Prettier over the command line. This way you can execute it via a shortcut, a keyboard shortcut, directly in VS Code. So install this as well. And then we make one more change to our settings. We want to change the default formatter and we want to set this to Prettier. And now whenever we format our code, for example via the keyboard shortcut, we will use Prettier for formatting. And Prettier is really useful because it adds semicolons, it adds line breaks at the correct places, parentheses and so on. I really love Prettier. And again, it also reorders the Tailwind classes into the appropriate order. You will see this later. And as usual, I always recommend that you have the ESLint extension installed as well. This way you get these lint warnings directly in your code, in your IDE editor, and you don't have to look into the command line to see them. You should have this installed no matter what project you're working on. Okay, so we use Tailwind in this project, right? But for this tutorial, I don't want to use a component library because our website is relatively simple and we can style this ourselves. And sometimes it's also useful to learn how to style your project from scratch yourself. But I want to steal the color variables from this component library from ChatCNUI, which is yet the most popular component library for Tailwind CSS at the moment, I would say. And we won't install these components here again because we don't need them, but I want to create a theme here and copy this into our project. Now again, I will already include this in the starting code, so you don't have to copy this yourself. In case you set up the project manually, I will also put a link to the code with these color variables into the video description. So you don't have to go to chatcn.com. Instead, you can copy the color variables directly from my video description, because I don't know if this page here will still work or still have the same link in a year or so. This is why I'd rather provide the code from my GitHub repository so you can copy it from there. So again, it's in the video description. Yeah, and here I want to create a theme, which we can customize. I want to use the blue color. This is how it looks in dark mode. Yeah, and I basically just want to copy paste this. So I copy this into my project. And this goes into the globals CSS file. We can remove everything except for these 3 lines here at the top. And again, I will put a link to this global CSS file into the video description so you can copy all these variables from there. Yeah, and this creates different color variables that we can then use in our Tailwind classes. Those are the colors that you just saw in the theme preview on the ChatCN website. It provides them for light mode and here for dark mode. And this way it's easier to style our website, because instead of writing, for example, background white and then dark colon background black for dark mode, we just have one background color variable. But on dark mode, it has a different color set to it. You will later see how we use these variables. So if this is confusing to you right now, don't worry. There's just one more piece of code we have to add below, which is this part. If you didn't download the starting code, again, pause the video and type this out. Make sure you spell this correctly. This just applies the border color to all borders. The border color is one of these variables in here. Down here it is. And this one sets the background of all pages to the background color and the text to the foreground color, which again is different in light and dark mode. Okay, we save this file, but those are just CSS variables. To make them available in our Tailwind classes, we open the Tailwind config file. Here we remove this background image block, and instead within the extend block, I paste a bunch of code. This connects all these CSS variables and creates the corresponding Tailwind variables. I will put a link to this file into the video description as well, so you can copy the code from there. You don't have to type this out by hand. I'm not a maniac. And one more change, we do this at the top. We add the dark mode key and set this to class. This is how we will later be able to switch between dark mode and light mode via a button, but we implement this later. And yeah, now our project should be properly wired up to start coding. Just one more thing, I also paste an image into this public folder. This is just this background shape that I want to show on the website later because it looks cool. Again, I will put a link to this PNG file into the video description so you can get it from there. Just put it into the public folder in your project and then we can start building our pages. Okay, so what I want to do is, first I want to build the website itself, the layout and the different pages, and then we will add our Langchain chatbot afterwards. Shouldn't take too long because we will keep this website relatively simple. First of all, we go into the root layout tsx file. And here we make a few changes. First of all, I want to change the metadata of this website. We remove this string here from the title and instead we add curly braces because this way we can set a template title. In here we write as a string %s, vertical bar, and then your name. This way it will generate this title where this part here is the title of the page itself, for example about or social or privacy policy or whatever, and this part afterwards will be appended to the page name in the title. Of course, you don't have to use the same title as I do, you can type anything you want in here. This is just an example. And when we use such a template, we also have to set a default title which will be used on the front page and on every page that doesn't have a more specific title. And here again, we can add our name or whatever you want. And then we can also change the description, and this sets the appropriate head tags for this page. This title will be shown, for example, in the browser tab, but also when we paste a link to our website on social media, and the description as well. Again, the description is up to you. You can write whatever you want. I'm going to write, check out my smart portfolio website with a custom AI chatbot. Then we go down here into the body tag and we surround the children with a main tag because all child pages will have the same structure, the same kind of layout. So instead of putting the main tag into each page, we can put it right here with some default styling for which we use Tailwind classes. We set a max width of 3XL so that the pages are not too big. Then we center this page on the screen with MX Auto. And then I also want to add some padding. Vertical padding with PY10 and horizontal padding with px3. And now when we press our format code shortcut, which you can find here in these commands, format document, and this is the shortcut. In my case on Windows that's Shift-Alt-F. When I press this, you will see that these Tailwind classes get reordered. Let's mess them up on purpose. Let's put this one here at the front. I press Shift-Alt-F and they get ordered. And it also puts the children and the closing main tag into the same line. This is what Prettier does. And this is pretty cool because then we don't have to think about this stuff. If this line was longer, it would put it into multiple lines again. Also, if we remove these parentheses here, for example, just to show you this and put this into the same line, and again press Shift-Alt-F, it adds the parentheses back in. This is what is so cool about Prettier. It's very opinionated, so it makes these decisions for you, and you don't have to think about this stuff. You don't have to think about, do I put parentheses here or not? Do I put the code into multiple lines? This is all done for you with one shortcut, and your style is consistent throughout your whole project, and also the class orders are consistent. Okay, then we save this and we go to the front page TSX file. The page TSX in the app folder that's in a new Next.js project by default. And then we remove all this content here, the whole main tag, because this is just example code. And the main tag is already in our root layout, right? So in here we don't put another main tag, we put a section. For now, let's just write front page and save this. And then let's run this project in development mode. In the command line, we execute npm run dev, which starts this on localhost 3000. We open localhost 3000 in a browser, and then we see our front page text here with the padding we applied to the main tag. And then let's style this page. First of all, above the component function, I want to export const metadata, make sure the spelling is correct, all lowercase, and this is of type metadata, which is an import from Next. This is how we change the metadata of a page in Next.js, the same way we did it here in the root layout. But this metadata will be page specific. Again, I want to set the title here to a string. Now, I explained earlier that the page title will be put into this template, right? And this Florian Walter will be appended after it. This is true for every page under this layout, but not for the root page, not for the front page, because this is the same level as this layout. So this template is not applied on the front page. Here we have to type out this whole format again, or we use a completely different title. So here I want to write my name again, minus my smart portfolio. And when we save this, this becomes the title of this front page. Okay, let's set up the layout of this page. First of all, we go to the first section opening tag and we add some class names here. The first one is space y16. This will add some vertical spacing to whatever elements we put inside this section. Then I want to add this background image, which we added earlier. Again, the link to this image is in the video description. Just put it into your public folder, because then we can access it here in our classes. We do this by writing bg minus, then square brackets. In here we write URL, parentheses, and in these parentheses we write two single quotes, and in here slash background.png, which is the name of this image file. And then we need to add some more classes. The next one is bg cover, which sets the size of this background image to cover. bg center centers it. bg no repeat makes sure that it's only shown once and not repeated. And then I want some extra horizontal padding with px1 and vertical py8. Okay, so right now this looks a bit weird, but this will look properly in a moment. Let's remove this front page text and add another section in here. And instead of sections, you could also use divs. Sections are just a little bit more idiomatic HTML code for independent sections of a page. So we style this second section as well with grid calls 1, items center, and you can always see the corresponding CSS attribute by just hovering over these classes. So we just add these to lay out the elements properly. Gap 8 adds some spacing inside the grid or a flex box. And later we put an image and some text on here. And with grid calls 1, we will have one column. So these two elements will be below each other. But we only want this on small screens. If the screen is big enough, we want to have them laid out horizontally. We achieved this by writing sm colon and then grid calls 2 instead of 1. So Tailwind classes are mobile first. So this class here will be applied on very small screens. And on the SM breakpoint, which is 640 pixels and upwards, we set grid calls to 2. So below 640 pixels, this one will be applied, and on bigger screens, this one will be applied. And just like SM, there are also other breakpoints you can use, like MD for medium screens, LG for large, and then different XL screens, which all have different pixel values. Okay, so then the first element inside this inner section will be a div with some text. To this div, we add the class spacey3, and in here I want to put an h1 headline and some text. In Tailwind, basically all HTML elements are completely unstyled by default. So even if we put an h1 in here, it just looks like normal text, like a normal paragraph tag. We have to style it ourselves. Now, of course, we will have many h1 headlines throughout our website, and I don't want to repeat the same styling over and over again, so we can extract this into its own component. So this is exactly what we will do. In our src folder outside of app, we create a new file, and then we write components / which creates a folder, UI / which creates another folder, and here we put in h1.tsx with an uppercase H. Yeah, and in here I want to put an h1 headline. So export a function with the same name, h1, props colon, and for the props type we use react.html props angle brackets, and in between the angle brackets we write HTML heading element. Make sure this is heading element and not head element. What we achieve with this type is simply that our h1 component takes the exact same props as a normal HTML h1 component. So we can use it just like a normal h1 tag. But we can add our own styling to it. So in this component we return an h1. Actually we give it a self-closing tag like this. In here we make a pair of curly braces and write ... props. This way we apply all the props that we pass to this component to this h1 headline by spreading them here. But we also want to override the class name. So we add a class name prop with our own styling. But instead of just hard coding the styling here, I still want to be able to customize this headline later when we call it. For example, we can pass a text center to it to render the text on the screen. So we can't just hard code the styling into the class name, because then we can't pass any additional classes from the outside. So in other words, we want to mix the classes that we put in here with the classes that we passed from the outside. For this we need to create a little utility function, because the order of these class names here actually doesn't matter in Tailwind CSS, because this is not how CSS applies attributes. It doesn't care about the order. But then you get the problem that a class that you pass from the outside might not be applied because another class inside here takes precedence. This is what we installed Tailwind merge for. it takes care of classes overriding each other in a way that works. And again, to use this, we create a little utility function. So again, in our src folder, we create a new file. Here we write lib / and in here we want to put a utils.ts file for utility functions. In here we export a function called cn. This is just a naming convention. I guess this stands for class name. To this function we pass a var arg with ... input like this of type class value array. But auto import didn't work, so we have to import this manually. Up here we import from curly braces, from CLSX, which is this other package that we installed. And in here we find the type class value. Now this works. We finish this function. And in here we return twmerge, which again we have to import manually from this Tailwind merge package that we installed. And in here is this twmerge function. We call this function here, parentheses, to it we pass CLSX, which again we call, and to it we pass our inputs. I actually want this to be plural, inputs. Okay, so this combines two Tailwind helper functions, CLSX and twmerge, into this single cn function. As I explained earlier, twmerge is responsible for overriding Tailwind classes, so that when we pass another class to our h1 component from the outside, it will take precedence over the internal styling and override it. And CLSX allows us to pass classes conditionally, which can be very useful. You will see how to use this in a moment. So we create this function here, export it, and then we change the class name in our h1 component from a string to a pair of curly braces, because then we can call our cn function, to which we can now pass multiple of these class values, as many as we want, separated by commas. And each of them is a string of one or multiple class names. So the first string in here is our default styling. Actually, before we add the styling, let's save this for now, and let's use this h1 on our front page so that we can see the styling here. So we change this lowercase h1 to an uppercase h1. It still looks like a normal h1 because we didn't add any styling yet. And now we want to style this. First with text 3XL to make this text large. Font bold, which is self-explaining. Dragging tight decreases the horizontal spacing between the letters, just looks a little bit better. And again on small screens and upwards, we want to make the text even bigger for responsiveness. So now on small screens, the title has a size of 3XL, and on large screens, it's a little bit bigger. But as I explained, we want to be able to change the styling from the outside. This is why we used our cn function. So within these parentheses here, we can add a comma and then another class value string. And here we simply pass props.className, which are whatever class names we pass to this component from the outside. And this now allows us to customize this h1 headline, but still keep the default styling. So just like a normal h1, we can add a class name to our own h1. This is possible because our h1 takes the same props as a normal h1. And for example, we can center the text. I want to have it centered on very small screens, and on small screens and upwards, I want to put it back to the left side, like this. Okay, before we continue with this page, let's also create classes for h2 and h3 headlines so we can use them later. So let's just copy paste h1 and rename it to h2. Call the component h2 and change the tag to an h2. And then we change the styling a little bit. Text 2XL, font semi-bold, still tracking tight, but I don't want to change the size on larger screens. I want to keep this at text 2XL at every size, but of course this is up to you. You can change this if you want. The rest stays the same, and then we do this one more time for H3. And of course, if you also need an H4 headline or H5, you have to create classes for them as well. So this one will be a text XL font semi-bold tracking tight. And of course we change the name to H3 and the tag to an H3. Okay, looks good. Yeah, and then let's just create a cool looking front page. For the title I want to write hi, I'm Florian, and this wave emoji which I just copied. Now unfortunately in React we have to escape these special characters like single quotes in our JSX code. So instead of the single quote we have to write ampersand sign, APOS, semicolon. Looks very weird, but this way we create a single quote here on our page. Of course you should use your own name instead of Florian. And then below this H1, still inside this inner div, I want to add a paragraph tag with some information about me. Again, I want to style this with text center and SM text start, just like the headline above. And here I paste some more text. I'm a full stack developer from Germany who builds cool projects and makes tutorials about them on YouTube. Just add some little text about yourself. Okay, then we go below this div here, between the div and the section. We create another div to which we add the classes flex and justify center. And in here I want to put an image of myself. For this I've put an image file into src and then the assets folder which you have to create, and in here I put an image of myself. So just create this assets folder in src and add an image of yourself in here that we can then use on the front page. And I also added this other image which I later use on a different page. Put all of these images into the assets folder. We put the background into public because otherwise we can't access it from our CSS class. But normally we put our images into src assets, and you can also put an image folder in here if you want, doesn't matter. But any image you want to add to your pages, to your content, you can put in here. Okay, here we put an image tag, an uppercase image, which is this next image here. We always use next images in a Next.js project because they have some nice features like automatically resizing the image to the appropriate size and also lazy loading. So first of all, we want to import this image of myself. I'm gonna call it me from add/assets/me.png, and then we use it down here as the src. And there is this beautiful giant face. Of course, we need to style this image tag. First of all, we set an alt text for accessibility, a photo of me. This is what screen readers will read. Then we set a fixed width and height to 300 times 300 pixels. And then we style this with some class names. I want to make this image a circle, which we can do with rounded full. And if the width and height of your image are not the same, it might be an oval instead of a circle. We can make sure that it's a circle with the same width and height by setting the aspect ratio to a square. Maybe you notice that the height got slightly smaller. I also want to set a border of 2. We don't really see it in light mode, but later in dark mode we will see it, and I just think it looks cool in dark mode. This is why I added. With object cover, we set the object fit attribute to cover. This way we make sure that the image doesn't look distorted when we change the width and height. Instead it will be center cropped. So everything that doesn't fit into the image will be cut out. Then I also want to add a shadow MD, again because it looks cool. And on dark mode, which we can do with this dark color modifier, I want to set the border color to border foreground. We don't have a way to switch to dark mode yet, so we can't yet see how this will look. We will see this later. But this foreground here is one of our color variables that we set up earlier. It's a different color in light and dark mode. And we have these special classes here available because we earlier set this up in our Tailwind config file by connecting them to the corresponding CSS variables. Okay, so this is the whole styling. Again, when we press the formatting shortcut, it's formatted properly and the classes are ordered correctly. We are almost done with this front page. Below this inner section here, I want to add another section with some more text. Again, we style this with space Y3 and text center. And our page already looks pretty cool. Here I want to put an H2 headline. We don't have to change the styling because it's already internal in this component. Ask the chatbot anything about me. And on small screens, grid calls 1 is activated, and when we make the screen bigger, we have 2 columns and these elements are next to each other. And then I want to put another paragraph below with some more text. Again, I'm going to copy paste this and I import this bot, which is an icon, but auto import again leaves me hanging, so I have to import this manually. Import curly braces from Lucid React, which is this icon package, and in here is this bot icon, which looks like this. And you can pause the video and type out this text, which just contains some instructions on how to use the AI chat. Okay, so go ahead, type this out, then save everything, and let's see how this looks. Looks pretty good if you ask me. Alright, of course you can change the layout if you want, but I think this looks pretty cool. Next I want to add a navigation bar to the top and a little footer to the bottom, and then I want to add some more pages. So let's create a new component in the components folder, not inside UI. There I usually put these more low-level components like headlines, but larger components I put directly into the components folder, like our new navbar. Export default function navbar, return, and here we return an HTML header. Again, we could also use a div, but a header is just a bit more idiomatic in HTML. And then we want to style this. We want to make it sticky, so it sticks to the top of the page when we scroll down, which we do with this Tailwind sticky class, which adds the position sticky CSS attribute. And then we have to set the position, which we do with top 0. And by default, this header will be transparent, but it should be overlaid over our other content, right? So we set the background color to BG background, which again is one of our CSS variables. This background color will be different on light and dark mode. Okay, into this header, we put a div. We set this div to a max width of 3XL again. And then we want to center this on the screen, just like our layout itself. So this part here is the header itself, and this part is the contents inside the header, which are centered. We also set this to flex, and then we add flex wrap, so that the elements will be laid out horizontally. But if the screen gets too small, then these elements will automatically move below each other for responsiveness. And I want to have the navigation on the left side, and the theme and chatbot button on the right side, which we can easily do with a flexbox by using the justify between class. So now whatever elements we put inside this div will be laid out with space between them. If we put two elements in here, one will be on the left side, the other one will be on the right side. Then a few more classes. Gap3, a horizontal padding of 3, and a vertical padding of 4. Maybe let's save it for now and let's put it into our layout before we finish the navbar. We go into the root layout and we put it inside the body, but above the main tag. Here we put our new navbar with a self-closing tag. And if we put some dummy text in here, we already see it. Okay, but of course I don't want this navbar to say ASD, ASD. Instead I want to have a navigation in here, for which we use the HTML nav tag, which again we style with space x4, which adds horizontal spacing, and we set the font weight to medium, which is not quite bold, but it's a little bit thicker than the default font weight. And here we put a bunch of links. We don't use A tags, we use next links, because they are better for internal navigation. The first one will say home, and it will simply link to the home page, and voila, there it is. Then I want to add a couple more pages. There is just one problem. Later we use OpenAI to create the vector embeddings for our pages. This is how we find the content for our chatbot on our website. The problem is if you have a new free account and you haven't yet paid anything to OpenAI, then the rate limiting is really strict. We can only make 3 requests per minute. You get to a tier 1 once you have paid $5 to OpenAI. Then the rate limit increases to 500 requests per minute, which is a whole different story. But if you have a free account, then this will just be enough to create vectors for one page, basically. So if you don't have a paid OpenAI account yet, and you have a free account with this rate limiting, then I recommend that you only create a single page for now and no other pages. Otherwise you might run into this rate limit later. So only create a front page, add some information about yourself, and later if you want you can add more pages if you want to pay some money to OpenAI, because these large language models, they always cost money. They are extremely cheap. You can generate thousands and thousands of words for a fraction of a cent. However, they are not free because creating these AI responses costs money and someone has to pay for it. So again, if you have a free account on OpenAI, then I recommend that you only create a single page for now. And then you also don't need any more links in the navbar. But I have a paid account on OpenAI and I can create more pages. So I will add a bunch more links here. The second one will lead to /about. But what pages you add in here is completely up to you. You can build this website in any way you want. I want to create an about me page with some information about me. And another one, as you saw in the beginning, that talks about my social media platforms and how people can get a shout out from me or cooperate with me. So just put some information about yourself on these different pages. And I want this to be all lowercase just because I think it looks cool. Okay, I will set up these pages in a moment. For now, let's also add a footer to our components folder. Footer tsx, export default function footer. Here we return a footer element, which again contains a nav, which again we style a little bit with max width 3XL, MX auto, flex, gap 3 and a padding of 3. And in here I put another next link, which will point to the privacy policy. Okay, cool. Again, those are just example pages, so that we have some text for our chatbot to work with later. Then of course we put this footer into our root layout below the main tag right here. And this is a very simple footer with just this one link. There it is. So now what I'm gonna do is I'm gonna create a bunch more pages for these different links I created, an about me page, a social page, and the privacy page. But I'm gonna do this off screen so it doesn't take too long, because those are just normal pages. There's nothing special on there, just some information about me. And similarly, you can create your own pages with information about you. Again, if you have a free OpenAI account, then you should probably just have the front page for now. Okay, so I created these different pages, for example, the privacy policy with its own title. And this title, since it's a child of our root layout, will have our template applied to it. So privacy policy, vertical bar, Florian Walter. And other than that, it just contains a section with a headline and some text. Again, what you put in here is up to you. If you want to copy this code, then you will find these files in the GitHub repository in the video description below. But I recommend that you set up your own pages with some information about yourself. You can also put images in here, like I did on the About Me page, for example, here of our Brazilian Jiu-Jitsu gang, and yeah, some information about me. You can also explain your skills on the page and really put anything you want on there. And these chatbots are smart enough to find the relevant information later, no matter how bad your writing style is. Okay, just one more thing I wanted to mention. Just like headlines, you have to style links yourself in Tailwind CSS, which you have to do with class names. So to all these links, I added text primary. Our primary color is this bluish color. And with this hover underline modifier, we make the link underlined when we hover over it. How you style this is up to you, but without this class name, this will just look like plain text, even though it's a link. Again, if you're confused about anything of this, you can find the full code in the video description below. And you can also add descriptions specific to a page. Okay, and next we will implement the dark theme, and then we can start implementing our chatbot. To implement a dark theme switch into our website, we will use the Next Themes package, which makes this very easy. Remember that earlier in our Tailwind config file, we set this dark mode class attribute. What this does is it checks if there is a certain class applied to the HTML tag of our website. I think this class is just called dark. Actually, let's try this out. When we save this, I think, yeah, we already see the dark mode. Because now on this HTML tag here, there is this dark class which tells Tailwind CSS that the dark colors should be applied. And the dark colors are part of our CSS variables. If you want to change them, you can change them here. But of course, we don't want to hard code this to dark mode. We want to change this dynamically via a button. And this is exactly what Next Themes does for us. It puts this dark class into the HTML tag, and it does it in a way that when we refresh our page, we don't see a flash of light mode before it switches to dark, which usually happens if we implement this ourselves, because the dark value is stored in local storage, and local storage only becomes available a short moment after we render the page. But with some dark magic, this library solves this problem. This is why we use it. And this is why I recommend using it in any Next.js project that should have a dark mode. So what we have to do is we have to wrap everything inside our body tag into a theme provider, which we have to import manually. Import, let's first add the from part from Next Themes, and then we should get auto-completion. And here is the theme provider. We want to wrap our whole body content with it. And we also add this attribute prop and set this to class, so that when we toggle the theme, it will change the class name on our HTML tag. But spoiler alert, this will throw an error. Why? Because this uses context internally, but it's not marked as a client component, so we can't use it inside our server component here. If you don't know the difference between client components and server components, I explained this in my Next.js app router beginner tutorial. But we can solve this problem pretty easily. We have to turn this theme provider into a client component, which we do by creating a new file in our components folder, which we give the same name, theme provider. We make this a client component with useClient, and then we simply re-export this theme provider from the next themes package, similar to how we imported it, just that now we write export instead. And then we want to change the import in our layout from next themes to the one from our components folder, because this is now a client component and now we can use it. Now, just for clarification, just because the theme provider is a client component doesn't mean that all our pages are client components too. Again, I explained this in my Next.js beginner tutorial. So those are still server components with all the benefits we get from them. Yeah, and the theme provider is a context provider, which gives us access to the theme itself, but also a function to toggle the theme. For this, I want to create another component, again in the components folder. Let's call it theme toggle.tsx. This has to be a client component because this needs an on-click handler and context, and this only works in client components. Export default function theme toggle. In here we destructure this use theme hook, which is an import from next themes. In here we get access to the current theme and the set theme function. And then we return a component here. This theme toggle will be a button, which shows either a sun icon or a moon icon depending on which theme is active. And when we click this button, of course we want to toggle the theme. So in here we can pass an inline function, but without curly braces, just a right arrow where we call set theme. And to this we have to pass a string, either light or dark. For this we check which theme is currently applied. So we check if this theme string up here that we get from the hook is equal to dark. Then we want to apply light mode. And if light mode is active, we want to apply dark mode, right? Yeah, and inside this button we put our icons, which again are coming from Lucid React. This is the import statement. Below we put a moon icon. And then I want to give both of them a size of 24 and some class names. To the sun icon we add the classes absolute, transition all, this one here, rotate 90, scale 0, and then dark colon, rotate 0, and dark colon, scale 100. You will see how this looks in a moment. To the moon icon we add transition all again, rotate 0, scale 100, dark minus rotate minus 90, and dark colon scale 0. Those are all the classes. This way we only show one icon at a time, because this one has a scale of 0 by default, so it's hidden, and it's only shown on dark mode. But the other icon is hidden in dark mode and only shows in light mode. And with transition all, we add this transition animation between these different modes, and rotate just looks cool. You will see this in a moment. Let's save this and put this icon into our navbar. Here below this nav, I want to put another div. Remember, this justify between will put this element to the left side and this div on the right side. And in here I want to put our theme toggle. And there it is. And now when I click it, it will change the theme, and you will also see this rotation animation, which just looks cool. This is why we added all these different classes here. And just like that, we have a beautiful dark mode, which is applied on all our pages. And when we refresh the page, we don't see a flash of light mode, and set it dark immediately. Again, the colors are coming from our CSS variables in here. So if you want to change the colors, you do this in the global CSS file. Alright, our page looks pretty beautiful if you ask me. And next we will add our AI chatbot. Next I want to build the chat box for our AI chat. So let's make this a new component. In the components folder, AI chatbox.tsx. Export default function with the same name. And this function will take some props. AI chatbox props. Because the color of this function will decide if this checkbox is opened or not. So we add an open prop of type boolean and then an onClose callback so that when we close this chat box, we can change the state in the parent. Then we pass these props to the component, we destructure them, open, onClose, and the type is of course AI chatbox props. Then we destructure a const and we assign this to use chat. Okay, again, auto import doesn't work. Import curly braces from AI/React, and in here is this useChat hook, which we call down here and destructure. This hook is coming from the Vercel AI SDK that we installed earlier. And this SDK is really useful because it makes it easy to implement the chat functionality with streaming. And it has helper classes to connect this to OpenAI and Langchain, which makes setting this up later much easier. You don't have to read the documentation. I will explain everything you need to know. And here we destructure a bunch of values. In here will be our chat messages later between the user and the bot so that we can render them in the UI. Input contains the current input state of the chat's text field, and handle input change changes this state. We later apply these two values to our input field, and to the form we pass this handle submit function, which takes care of sending these chat messages to an API endpoint. And the way this works is that useChat automatically calls an endpoint that looks like this, /API/chat. We later have to set up this API endpoint here in our project. You can also change this endpoint if you don't want to call it chat with this API value. You could set it to /API/blah or whatever. By default, it's set to chat. And when we call handle submit, it will send the messages and the current input to this endpoint where we then take care of the rest. A bunch more values we want to destructure here. With set messages, we can later make our chat empty again by setting this to an empty array. Is loading contains the loading state and error contains the error state. All of these values are coming from this useChat hook. And then below, we want to return a div that contains the chat box itself. Of course, we style this div. And again, we want to call our cn function here. This time not because we want to apply styling from the outside, but because we want to apply styling conditionally. If open is true, we want to show the chat box, otherwise we want to hide it. And we can do this with the cn function as well. So the first string is the default styling. We want to position this chat box at bottom 0 and right 0. We want to give it a z-index of 50. This way the chat box will always be placed on top of other elements with a lower z-index. We want to set the width to the full screen, but we also want to set a max width to a fixed pixel value, which we can do with square brackets. Max minus w minus square brackets, and in here we write 500 pixels. This way, on small screens, the chat box will take up the full width, but it will not get bigger than 500 pixels. Then I also want to set a padding of 1 here, And then on large screens, so XL onwards, I want to set right 36. What this simply does is, on smaller screens, the chat box will be all the way on the right side of the screen. But if the screen is very big, then I don't want this to be all the way to the right because it's far away from the main content of the page. Instead, it will be indented by this 36 value, which is 9 RAM or 144 pixels. So it will be moved a little bit more towards the middle of the screen horizontally. You will see this in a moment. Okay, and then I said I use the ZN function here to apply classes conditionally. So after a comma, we check if open is true. Then we want to set the position to fixed, because this way these attributes here get activated, the bottom and right positioning. And if open is false, we want to set display to hidden to hide this chat box. Okay, maybe for now let's just put a text in here again, chat box, and put this into our layout. For this I want to create another component that has a button which opens this chat box. And it will also contain the chat box itself to render it. So in our components folder we create a new file called AI chat button.tsx. And this is very similar to what we did in my other AI tutorial. There we had a similar chat box, I just improved this one a little bit. Again, this needs to be a client component. Then we export a default function called AI chat button. Doesn't take any props, but it will contain a state. Square brackets, chat box open, and set chat box open. We call use state and initialize this with false. By default, the chat box is closed. Then we want to return a button. When we click this button, we want to set chat box open to true, and we can later close the chat box from within, from a close button we put above the chat box. And in this button, I simply want to render the spot icon with a size of 24. Okay, but this is just the button. I also want to put a chat box in here to render it. To do this, we could wrap this into a div, but we can also wrap this into an empty fragment because the div is unnecessary. And by using a fragment, we don't add this unnecessary div to our layout. Next to the button, I want to render our AI chat box, which expects the open prop, which we assign to a chat box open, and the onClose callback, which will call set chat box open and set this back to false. And that's it. Let's save this and put this button into our navbar. Above the theme toggle, AI chat button, which also contains the chat box. And there it is. Yeah, we need some spacing, which we do via this div wrapper. Flex, item center, and a gap of 4, let's say. Now we have some spacing, and when we click this button, we see down here this text that says chat box. And this is where we want to put the actual AI chat box. So let's go back into this class. So let's remove this text, and the first element I want to put in here is the close button. So we add a button, and the onClick handler will call the onClose callback, which we pass to this component. And then we style this button a little bit. We add the margin bottom of 1. We put the button on the right side with MS Auto, which stands for margin start auto. And we set display to block. We close this button tag, and in here we put an icon, X circle from Lucid React. We set the size to 30, and we style this as well. We make this a circle with rounded full, and we set the background to BG background. Let's save this, and there is our close button. So now when we click this button, it should disappear because the whole chat box closes and we can open it again via our button up here. Fascinating. Okay, so this close button will be placed above the chat box itself. So below this button here, we put another div, which again we style. We make this a flex box. We give this a fixed height of 600 pixels, again with the literal value syntax with the square brackets that we used earlier. We place the elements below each other with flex col. We make this chat box rounded. We add a border. We set the background to BG background and shadow XL. Those are all the classes. So type them out. And in here we add another div, which will contain the chat messages. And below the chat messages, we will have the text message input field. So there's already a chat box with a height of 600 pixels. This is how it looks in dark mode. This is how it looks in light mode. Yeah. Now let's add some class names to this inner div. It should have a margin at the top with MT3. I want this to take up the full available height. And then we set overflow YOrder, which adds a scroll bar when we have too many chat messages to fit into this field. And we add some horizontal padding here as well. Yeah, and then we basically want to take these chat messages, which is just an array, and we want to render them in here. But of course they should have a good looking layout. So we create another component below, still in the same file. We don't have to export it. We only need it inside this file. Function chat message. And it will also take props. Interface chat message props. And it will take one of these messages here. And the type of this is message, which is coming from this AI package. So here let's write message colon and then import this message type, not from PostCSS, but from AI React. So it should add this import statement here next to useChat. Okay, we pass this to this chat message component. We destructure it in here from chat message props. And then we want to destructure this message further with colon, curly braces. In here we find the role, which is either the user or the AI assistant, and the content, which is the chat message itself. This is what we want to render on the screen. Then I want to create a const isAIMessage, which we assign to role is equal to assistant. I just create this variable so that we don't have to repeat this code here over and over again. This is just a bit more concise. And then below, we return the layout in form of a div. Maybe for now, let's just render the role and the message in here and continue the styling later. So role, message, like this. And just render them in the UI. And we finish the styling later. So here inside this inner div with the overflow Y, we add curly braces. We want to take the messages and map them like this. Right arrow, parentheses. Attention, this is not curly braces, those are parentheses, because this way we return whatever we put between these parentheses. And we want to return one of our chat message components. For the message, we put the message of this map iteration. And since we render a list, we also have to pass a key, which we can set to the ID of the message, which is part of this message type. Yeah, let's save this and see how it looks. Now, of course, we don't have any messages yet, But we can actually pass some initial messages here in the useChat configuration. Let's do this just for a moment. Initial messages in form of an array. In this array, we put a bunch of objects. So we have to pass an ID. Just gonna set this to 1. The role of this one is assistant. And the content will say, hi, I am the chatbot. And there's our first message. Let's add another one for a user message. ID tour. The role is user. Hi, I am the user. Nice. Later we will remove these initial messages, but for now they are useful so that we can style our chat message component. Okay, let's do this. Let's go inside this div here in our chat message. Add class names. In curly braces we call our cn function. We add mb3, flex and items center to add some spacing and alignment. And after the string, still inside cn, we write a comma. Because here we now want to check if this is an AI message. Then I want to align the message on the left side. And if it's a user message, I want to have it on the right side. So if AI message is true, we add the margin end of 5. And set this to justify start. And otherwise the opposite. Margin start of 5 and justify end. Cool, and the alignment already works. Let's get rid of this text here. Instead, we first check again if it's an AI message. And this is why I created this variable, so that we don't have to repeat role equals assistant over and over again. If this is an AI message, I want to render the bot icon again. The default size is fine. I want to add some margin on the right side. And flex none makes sure that this icon doesn't shrink. When the message gets too big, this icon will always maintain its size. Okay, then below this expression, we want to render another div, to which again we add class names. Again, we use the cn function. This will contain the background color and the actual chat message. We make this rounded with rounded MD. We add a border, some horizontal padding, and a smaller vertical padding. Then again, as the second argument, I want to put an expression. If this is an AI message, I want to set the background to the default background color. Otherwise, I want to have the colors inverted. So for user messages, we set the background color to our normal foreground color. You will see how this looks in a moment. And we set the text to the background color. Yeah, and inside this inner div here, we can just render our content. And now it looks much better, doesn't it? But remember that we also want to format markdown in here in case the bot sends links or lists. But right now, of course, this is just plain text. So let's add another dummy message here from the assistant that contains some markdown. Yeah, maybe we make this a backtick string so that we can write over multiple lines. And let's put a link in here, which in markdown looks like this. http:// codingandflow.com and the text of the link behind it. At least if I remember correctly, there should be a markdown link. And maybe let's also put a list in here. List colon, and the list looks like this. Item 1, item 2, item 3. But of course, this is not rendered as markdown yet. This is why we installed the React Markdown package earlier, which can format the markdown for us. So let's import this. Import React Markdown from React-Markdown. Then we scroll all the way down again to our content here. and we wrap this into React Markdown. Close this, put a closing tag here, and we already get a little bit of formatting, and my link syntax is actually wrong. The URL should be here in the parentheses, and the text of the link goes here in the front. Okay, but React Markdown has problems with this backtick string because those here in the front are actually empty spaces. So we have to remove these empty spaces at the front of each line, like this. And now when we save it, it is formatted as Markdown, whereas before it was just a raw string. Now when we inspect this in HTML, those are actually list elements, and this here is a link, because React Markdown takes the Markdown and turns them into the corresponding HTML elements. So you have to get rid of these leading white spaces here. Man, I swear backtick strings in JavaScript are the most awkward thing to work with. Anyway, our Markdown here has no styling yet, right? We want to style this via Tailwind class names, of course, and we can do this by adding this components prop to React Markdown, to which we add another pair of curly braces. And in here we can override what component is returned for each element. For example, we can pass a colon, with which we can decide what we want to render for every link. This expects a function, so we add parentheses, and in here we destructure a bunch of values. Node, comma, ref, comma, and then the remaining props, which are all the props of this link, like the href, for example, or the text inside the link. Then we return a component, again with right arrow and parentheses. But instead of using an A tag, we want to use one of our next links here, because those links are mainly for internal navigation. The chatbot will usually provide links to our own pages, but this link will even work if it's an external website. Okay, to this link we spread all the props. And the reason why we destructured node and ref separately is because we can't pass them to our link. It won't accept them. And this way they are not part of these res props. If we remove this here, they become part of these props, and then our link will not accept these values. So we destructure them separately so that we can ignore them, basically. Then we also have to set the href manually. Even though the href is contained in this props value, this can actually be undefined, but the next link doesn't accept an undefined href, so we have to provide a fallback for which we will use this empty string. But this href should never be undefined, because every link in our Markdown has a URL where it points to, but we still have to handle this case here in TypeScript. And then we want to style this, again with text primary and hover underline. Close this, and as soon as we save this, our link is styled. And you can do this for every Markdown element. Headlines, paragraphs, all this stuff. Now I don't want to waste too much time, and our bot will probably not print too many headlines. So here we will just handle links, paragraphs, and lists. This should be enough, and you can later add more if you want. So after a comma, p colon, again parentheses, curly braces, again we destructure the node, and then the rest props, and again we want to return a component. This time we just use a normal p tag, which is also what React Markdown returns by default. The difference is that we want to style this a little bit. First of all, we spread the props here. Then we add class names, we add a margin top for each paragraph, and then we write first colon empty 0, so that the first paragraph doesn't have a margin at the top. We close this, and then each paragraph will have some margin. And then I also want to handle unordered lists. Again, node colon, comma, rest props. Again, we return the same UL element with the same props. just with some styling. Empty3 list inside, which changes the placement of the items in the list. List disk, which adds these circles here. And again, the first list should not have a margin at the top. Actually, it's not the first list, it's the first child in this parent container. So if our chat message starts with a list, we don't want to have a margin at the top, right? And this is how we handle this. Lastly, I want to add some styling to these list items, and then that's it for now. So again, li for list items. Again, node and rest props. We return a list element where we spread the props. And here we add a small margin top of 1. And that's basically it. Just to get some more spacing between these list items. Okay, so the markdown styling is enough for now. Let's remove these initial messages from the useChat hook. Instead, I want to put an empty screen into our chat box. We do this right below our messages.map call here. We put another expression. First, we check if there is no error, which is coming from the useChat hook up here. If there is no error and messages.length is equal to 0, then the chat box is simply empty. The user hasn't sent a message yet. In this case, we want to render another div, which we have to close below. In here, I want to put the bot icon again with a size of 28. Below, I want to put some text that says, send a message to start the AI chat. There it is. I also want to align them vertically, so we style this div wrapper with flex and flex call. I want this wrapper to take up the full available height. And then we want to center the content with items center and justify center. We also add a gap of 3 to add some spacing between them. And then we will put some more text below. I want to center all of this text with text center. And I want to add some horizontal margin of 8. Okay, add all of these classes. Then I also want to style this paragraph tag. Want to make this a bit bigger with text LG and font medium. Now it looks like this. Then I want to put another paragraph below. This one is unstyled. This one will say you can ask the chatbot any question about me and it will find the relevant information on this website. Of course, you don't have to type this out if you don't want to. And here you just saw another really cool feature of Prettier. It automatically wraps this text into a new line when it becomes too long. So I can mess this up however I want, press the formatting shortcut, and it's put back into 2 lines. This is really useful and cool, so let's do it one more time below, just for the fun. So another paragraph. This one should be a small text with text muted foreground, which gives this grayish color, which also adapts to dark mode. And this one will say PS : if you want to learn how to build your own AI chatbot, check out the tutorial on the, again we press the formatting shortcut, and then I want to write the coding in Flow YouTube channel, but I actually want to make this a link, so I highlight this, Ctrl+Shift+P, embed wrap with abbreviation, and then we can wrap this into an anchor tag like this. The href of this link is my channel URL, And I would be really happy if you leave this in your sample to help me promote this video to more people. Again, I pressed the formatting shortcut, which puts this into a new line, and it adds this empty space here in an expression, because otherwise we have the problem that there is no space between the there and the link. So we have to do it like this. And then we also have to style this link as usual with text primary and hover underline. Great. So this is the empty text that will only be shown when there is no message in our chat yet. I also want to handle two more cases. When the chatbot is loading, but it hasn't started streaming yet, then I want to show a message that says thinking or typing or whatever. And I also want to show an error message if there's an error. Let's put this above this empty view block that we already created. You can also put it below, but I like this order more. So another expression which checks that is loading is true, but we only want to show this message if streaming hasn't started yet. We can do this by checking if the last message is from the user, because if the last message is from the AI, it has started streaming already. And in this case, we don't want to show this message. So let's put this logic into a separate variable above the return statement, just for organization. Const last message is user. And here we check if messages at the last index, which we get with messages.length -1, because the index is 0 based. Then we use the save call operator because this messages array could be empty, but if it's not empty, we want to check if the role of the last message is user. Then we know that the last message is by the user. And then we can use this down here. We check if is loading is true and the last message is by the user. Then we want to render a chat message which expects this message prop, right? Which we can hardcode in here between two pairs of curly braces. Here we have to pass an ID. Let's set this to loading. We need a role, which is the assistant. And the message will say thinking, ... So that the user has an indicator that the AI message is currently loading. And if there is an error, I also want to show a chat message. So again, we add another expression below. We check if error is true, in which case again we render a chat message, to which we pass a message object. We set the ID to error. Again, we set the role to assistant. And the message will say, something went wrong. Please try again. And this should be 2 ampersand signs instead of 1. And our chat box is almost done, but we still need an input field, right? So that we can even send a message. So down here, we have 3 closing divs. We go above the second closing div from the bottom. And in here we add a form. This form will be handled by the Vercel AI SDK via the useChat hook. We pass the onSubmit prop here and pass handle submit to it, which remember we destructured from useChat. We just pass it here, and then submitting the form is handled automatically for us. We style this form with a margin of 3. We make this a flex box and add a gap of 1. And in here we put an input field, a send button and a clear chat button. The clear chat button will be on the left side, so it's the first element. And this will just render a trash icon, again from Lucid React, with a size of 24. There it is. Then we add some props to the button. We set the type to button to avoid that this button submits our form, because this is not what this is for. We style this button. We make this a flex box. We want to center the icon inside it with item center and justify center. We want to give this a fixed width of 10. And then I also want to avoid that this icon can shrink, which again we do with flex none. Okay, then I also want to add a title, which says clear chat. This is useful for screen readers, and it's also shown when we hover over this icon, so that we know what this button is for. And then how do we actually clear the chat? This is simple. We pass an onClick handler, which calls the setMessages function and sets this to an empty array. Remember, this is another value that we destructured from useChat. This way we can make this messages array empty. Then below the button, still inside the form, we put an input field with a lowercase I, which gets a self-closing tag. This input field is managed by the useChat hook. So we wire it all together. We set the value to input, which again we get from the useChat hook. For onChange, we pass handle input change. We can also set a placeholder, which will be shown when the input field is empty, like say something. And then this input field is unstyled by default. We want to style this. With grow, we can make it take up the full available width in this parent form, which is a flexbox. I want to give this a border as well. Make this a bit rounded. Set the background color to BG background and give it some vertical and horizontal padding. Now it looks decent. And finally the submit button below, but we can also submit this via the enter key, which is really useful. But we can also click this button. This will contain an icon again. Send horizontal from Lucid React. Again we set the size to 24. I want to use the same classes as on this other button, so let's copy the class names, paste them here. I just want to add one more class. When this button is disabled colon, I want to make it a bit transparent with opacity 50, because we will disable this button if the input field is empty. And I also want to make this button disabled while the AI chat message is loading or streaming in. But this didn't work properly when I tried it out. So we're gonna add it here, but we might have to remove it later, or maybe find a way to fix this. Because the problem I had was that the send button didn't get enabled again, even after we received the assistant message. But again, we will add this now and then see if we have to fix it later. Maybe the problem was somewhere else. So we set disabled to is loading, or input.length, oops, that's the wrong one, input.length is equal to 0. Then this button is disabled and a bit transparent until we type something in. Then we also have to set the type of this button to submit, because it's inside a form, and this way the form will be submitted when we click this button. And let's also set a title here, which will say submit message, which again is shown for screen readers or when we hover over this icon. Okay, that's a pretty nice chat box if you ask me. Just two more things I want to do. When we open the chat box, I want the focus to automatically be on the input field. Also later when we receive new chat messages, I automatically want to scroll to the bottom all the time, like it works in any other chat app. We can do this via refs in React. For this we go above the return statement. I'm gonna put it here below the useChat call. We create a const input ref, and we create a ref via this useRef hook, which is an import from React. The type of this ref is HTML input element. That's the element we will assign it to, and we initialize it with null. And then we create another ref which we later use to scroll down in our chat message history. Again, we assign this with useRef. This will be an HTML div element. And again, we initialize this with null. Okay, then we scroll down to the div that has overflow y_auto, because this is the one that can be scrolled. And to this we pass the ref prop and we pass our scroll ref. So now we have a direct reference to this div and we can do stuff like scrolling down when something happens. And similarly, we assign this input ref to the input field down here. So ref equals input ref. Okay, and now we only need some logic that actually does something with these refs. Again, we do this at the top. Let's put it right here, below the lines where we declared the refs. We add a use effect, parentheses, and here we pass an arrow function with a block of curly braces. And to the dependencies block of this use effect, we pass our messages. Because every time this messages array changes, by adding a new message, we want to execute this use effect, which will then simply scroll down. In here we check if scrollRef.current, so if the ref has a value, which it will have because we assigned it to the div, but we still have to handle it here because it could be null. Then we call scrollRef.current.scrollTop equals scrollRef.current.scrollHeight. This is the code that's necessary to scroll down in our chat box. Unfortunately, it's quite verbose, but this is how we have to write this. Then we need another use effect that focuses our input field when we open the chat box, and then we are done with this component. So another use effect with an arrow function. This one will be triggered every time the open prop changes. Here we simply check if open is true. Then we want to take the input ref this time. Then we use the save call operator because again current could be null. And then we simply call this focus function on it. And we can already try this out. We can close this chat window, open it, and the focus is automatically in the input field, which is very convenient because then the user can start typing right away. Now when we send this, it doesn't work yet because the endpoint doesn't exist yet, so we see this error message instead, but later here will be the actual chat messages. Okay, this was a lot of work, but now we have a very nice AI chat box. And next we will implement the actual AI chat functionality. Okay, to make requests to OpenAI, you need an API key. For this, go to openai.com, create an account here if you don't have one yet, and then create an API key. I trust that you can figure this out yourself. It has been a while since I set up my account. They used to have a free quota. I don't know if it's still available. And the API does cost money. There is no way around this, unfortunately, because running these models costs money, but the API is super cheap. We will use the 3.5 turbo model because this is the cheapest one that still performs really well. 1000 tokens is about 750 words. So as you can see, for 1/10 of a cent, we can generate 750 words, which is quite a lot. So yeah, create an account here, create an API key. Then we go back into our project. And then we have to create a .env file. So we right click in the root folder, not inside any of these other folders, right here. Create a file called .env.local. Make sure it's spelled correctly, because this is the .env file where Next.js will by default look. In here you add your OpenAI API key. Add it with this exact name, because later when we initialize OpenAI, it will look for an API key with this name. OpenAI_API_key in all uppercase. And before you get any ideas of using my API key here, I will of course delete this one after recording this video. Okay, and as I explained, this useChat hook automatically makes a request to /API/chat. So let's create this route in our folder here. So we right click on app, create a new file, api/chat/route.ts to create an API route handler under this URL. Now, as I explained in the beginning, Langchain makes it easier for us to combine different API tools together and also to handle different steps along the way, like loading our documents, splitting them, rephrasing questions, and so on. But Langchain is not necessary, and to get started in an easy way, I want to first make a request directly to OpenAI without Langchain, so that you can see how this works without getting overwhelmed. So for now, we just make a normal request to OpenAI. To create an endpoint here, we export an async function. Make sure that this is not the default export, then it will not work. It's just a normal, non-default export. And the name of this function has to be post in all uppercase, because the useChat hook will make a post request to this endpoint. And here we get passed this request, which will contain, for example, the chat messages. We add a try catch block because this can throw an error if something goes wrong while making our request to OpenAI. In the catch block, we return response with an uppercase R, .json, parentheses, curly braces, and in here we return this error field, which will just say internal server error, so that we get some feedback if we call this endpoint directly. Then we want to get the chat messages out of the request, because useChat sends these messages to this endpoint. So first we need the request body, which is in JSON format. We can get it with await rec.json, which is a function. And in this body are the messages. So we create a const messages equals body.messages. The type of this is any, because the body isn't typed by default, but for now we will ignore this. Then we need an instance of OpenAI. So we create a const OpenAI equals new OpenAI, which is an import from the OpenAI package. In here we could pass the API key, but if you gave your API key this exact name, then this is not necessary, because it will automatically look for an environment variable with this name. And if you have never worked with the ChatGPT API before, we can basically send chat messages to it and then have it generate the next AI chat message as a response to the existing chat history. We can also give the AI instructions in form of system messages. We can do this by creating a system message. So let's create a const system message. I also want auto completion here. So we set the type to chat completion message param. It's an import from AI/prompts, this one, because now we get auto completion here. For example, the role, which this time we send to system. Again, system is for instructions, which are neither user nor AI messages. And in here we pass a message, which will say, you are a sarcasm bot. This is just for now. Later we will turn this into our portfolio bot. For now, just for testing purposes, we create a sarcasm bot. You answer all user questions in a sarcastic way. And this is how you give these AI chatbot instructions. You write this as a normal English sentence and they will understand it. And then below we make the API call to OpenAI. So we create a const response. We call await OpenAI dot chat dot completions dot create parentheses curly braces. In here we define the model that we want to use. We want to use ChatGPT 3.5 Turbo, which is relatively cheap but still very good. We also want to set stream to true so that we can stream the response. And then we have to pass the message history to it. We pass messages, but we also want to add the system message and then the messages from the chat, so that we always have these instructions in the beginning. So we pass an array, we pass the system message, and then we spread the remaining messages from the useChat hook. And then we want to stream this response. And even though streaming is a complicated topic, the Vercel AI SDK takes care of this for us via some helper classes, and this useChat hook automatically handles streaming for us. So this will just work. These messages here will be streamed in automatically, even though they just contain normal strings, but they will be streamed in and this will just work. We just have to make sure that we set stream to true. Then below, we create a const stream. We assign this to OpenAI stream, which is an import from AI. That's the Vercel AI SDK. To it, we pass the response that we created up here. And below, finally, we return a new streaming text response to which we pass the stream. And that's all. And now this will just work. Just one more thing. Here is a typo in the error message. And after this JSON body, I also want to set the status code, which we can do with another pair of curly braces. And I want to set this to 500, which is a proper error status code. Oh, and one more thing. Before we return the error response, I also want to log the error to the console. But that's it. So let's try this out. Let's open our page. Let's refresh it just to make sure that the changes are applied. And now I ask our sarcasm bot something. Hey, how are you? Thinking, streaming, and a sarcastic answer. And we can even write follow-up messages. That's funny. And it will answer again. So this bot can't interact with our website yet. It doesn't know anything about our website. It's just this basic sarcasm bot. But I just wanted to show you how easy it is to set up this OpenAI request and get our chat to work. And next we will implement Langchain and add all of this cool functionality. But again, I will take you through the process step by step. Start as simple as possible so that we don't get overwhelmed. Because Langchain is actually quite a complicated package in my opinion. But don't worry, I will hold your hand through the whole process. You don't have to be scared. And at the end, we will have a very cool chatbot. Okay, so as I explained before, the benefit of Langchain is that it allows us to combine different tools, different steps, and sometimes even different language models to build more complex AI apps, because what we have here right now is very simple. We just send a prompt to a ChatGPT and we get back an AI message. But there are a few more steps involved to get the actual AI chatbot behavior that we want. And for this, Langchain provides different helper classes. For example, we want to read the contents of our pages, right? So we have to load them in some way. And for this, Langchain provides different loader classes. And they have a ton of them. For example, we could load files directly from a GitHub repository. We can also load a page from a URL. In our case, we will load our pages from the file system so that they are available when we compile the project. And then we pass the information out of these pages. Then next, we also have to split these pages into smaller chunks, because you only have a limited context window that you can send to the OpenAI API. So this system message here cannot be indefinitely large. There is only a certain amount of characters that we can send to OpenAI. Now this context window is very large, so we can send a lot of text. But the more text you send, the more expensive the request is. So it's always a good idea to only send the necessary data to it. And we achieve this by splitting up our large pages into smaller chunks. And again, Langchain provides different classes for that, for different use cases, depending if it's text, code, HTML, markdown, and so on. Next, there is another interesting problem that we need to solve. As you saw before, we can send follow-up questions to our chatbot, right? So we can ask, do you have a TikTok account? The bot answers, and then next we ask, can you give me a link to it? And the bot is smart enough to understand that the second question belongs to the first question. But in order to only fetch the data that we actually need, it's useful to rephrase these two separate questions into a new one. So if we ask, do you have TikTok? And then we ask, can you give me a link to it? It's useful to rephrase it into, give me a link to your TikTok account or something like that. Because then it's more likely that we find the relevant information on our website. And this is even more important if we change topics and ask a completely different question. Like first I ask, give me a link to your TikTok account, and then I ask, what are your hobbies? Then suddenly the first question is not relevant at all anymore for our query. So it's useful to only focus on the second question. And the way we achieve this is by sending our chat history to a ChatGPT first in a separate prompt and ask it to rephrase it into a new search query. And again, Langchain has helpers that do this for us. You will learn how to use them in this tutorial. And Langchain also has a lot of other tools, for example, to create agents that can execute certain tasks or to give your chat long-term memory. You can find out more by checking the Langchain.js documentation. So Langchain is really useful to build these more complex AI apps. The downside is that it also makes our code more complicated because Langchain needs to be able to work with so many different tools. They add their own abstraction layers on top of the stuff like OpenAI, which makes the code a bit more complex. But the benefit is the code is also more modular and you can more easily replace certain pieces of it. For example, if we later decided we want to use a different language model than OpenAI, then replacing it is easy with Langchain. But instead of talking too much about it, let's just write some code. And again, I want to start simple. I actually want to rebuild the same functionality we have right now with our simple sarcasm bot in Langchain, so that you can see the difference between Langchain and the vanilla OpenAI approach. So first of all, we delete this OpenAI client. Instead, we use Langchain's own OpenAI class, because again, they add an abstraction layer on top. So we write const chat model. We assign it to a new ChatOpenAI, which is an import from Langchain OpenAI. And then we can configure this. Again, we don't have to pass the API key because this is automatically read from our .env file. But we have to set the model name here this time, not where we make the request, but up here where we initialize the client. The same GPT 3.5 Turbo. We also enable streaming here. And this time we have to handle streaming a bit differently. For this, the Vercel AI SDK provides another helper called Langchain Stream. And this basically provides us with some callbacks that we have to pass to Langchain. So what we do is above the chat model, we create a const which we destructure, and we call this Langchain stream class from the AI package. And in here, we find this stream object and these handlers. And we pass these handlers to the callbacks field of this ChatOpenAI object. But attention, we have to pass them inside an array. So square brackets, handlers. This complains because now we have two variables called stream. We delete the one down here, the OpenAI stream. Then we want to get the last message out of our messages array up here. So let's do this at the top, below our messages object. Let's create a const and call it current message content. So the content of the last message. For this, we access the messages array at the last index. So messages.length, length. We don't get auto completion here because the type of this is any. So make sure to spell this correctly. -1. And then we only need the text out of this message, which is in the content field. And we also don't pass the system message like this anymore. Instead, Langchain has its own templates. So above, we create a const prompt. And then we use this chat prompt template class, which is an import from Langchain/prompts, and call from messages, to which we pass an array. But I think the import is wrong. We will actually get a warning message in the console if we use this one. We should get the chat prompt template from @Langchain /core/prompts. So change this, make sure the other imports are correct as well. And whenever something in your code is not working compared with the code in the GitHub repository in the description, I have a separate branch for each part of this tutorial. Okay, back down to our chat prompt template. Now we want to rebuild this prompt just with Langchain's template class. So in here we can send different chat messages, similar to what we did down here. But now we don't use curly braces here, we use another pair of square brackets. Then the first string again is system, who is sending this message, comma and the message itself, for which again we want to use this prompt here. So we paste it here, and then we add a second message, again with square brackets. This one is the user message. And for the text, we add such a placeholder here with curly braces, and in here we put input as a word. But there is no $sign here. This is not a JavaScript string template. This is a special Langchain template. So now we don't need this system message down here anymore. This is now in our Langchain template. And we also don't need this stuff. All this configuration happens directly here in the ChatOpenAI object. So we delete this, and instead we create a const chain. This is just a naming convention. We take this prompt, which is our chat prompt template. We call pipe and pass the chat model to it. This way we execute this prompt via our OpenAI chat model. And then we only need to invoke it with chain.invoke, parentheses, curly braces, and then we have to pass this input here. We pass it down here, and then it will be put into this template. So again, Langchain adds a lot of these abstractions, and I understand that the code is getting more complicated than it was before. So for simple AI apps, I actually don't really like this because it's too complicated. However, Langchain really shines when you start combining multiple different tools and steps. And then again, it's also easier to replace single pieces in our chain because we don't have to change the implementation. But yeah, the downside is it's a bit harder to understand, but if you read the Langchain documentation, then you can wrap your head around it. Anyway, here we have to pass the input value, which is the current user message content. This is what we want to put here into this user message. This is the last message the user sent in our messages array, in our chat. Let's save this, and now of course this also means that we only send the last message to our AI at the moment. We don't send the whole history anymore like we did before. We will later change this to send the whole chat history, but for now this is fine. And I think we should be done for this step if I didn't forget anything. So let's save it and try it out. Let's refresh our page on localhost, and now the sarcasm bot should still work the same. Hey, how are you? Just that this time we are using Langchain. Yeah, and we still get our sarcastic answer. And by the way, Langchain also automatically retries these OpenAI requests 6 times by default if we get an error here, which is really cool. You can customize this. I think it should be somewhere in here. Yeah, max retries. And there's also other configuration in here, but this is very useful. So this was a short introduction into Langchain, and next we want to add more and more steps to our chain to make our bot more and more powerful. Okay, so the next question is, how do we make our bot find the relevant information on our website? Of course, we could just pass all the pages in text format to OpenAI and ask it to find the relevant information. But as I explained, these LLMs have a limited context window. We can't send like 5,000 pages to it. And again, the more text we send there, the more money we have to pay. Instead, we use a technique called vector embeddings and similarity search to find only the pieces of information we care about. And I will try to explain this topic to you with my amazing paint skills. So OpenAI has special endpoints that can turn pieces of text into so-called vectors, and these vectors are basically just arrays with a lot of numbers in them, around 1,500 numbers to be exact. And these numbers, They represent a position in a room with 1500 dimensions. Now, of course, our human mind can't understand 1500 dimensions. We can only understand 3 dimensions basically. So this is supposed to be a 3-dimensional room, and this vector embedding we create, this large number array, contains a certain position in this room with 1500 dimensions. So for example, this could be a paragraph that talks about my TikTok accounts. So we take this text, turn it into this array, and it gets a position in this room. And the cool thing is, now every other text that has a similar meaning, so it also talks about TikTok, or maybe it talks about social media in general, will have a position close to this vector here. So the closer our texts are in their meaning, the closer they will be as vector embeddings, the closer their numbers will be. If we talk about a completely different topic, like what are your hobbies, then the position of this other vector that talks about the hobbies will be further away from the vectors that talk about TikTok or social media, because the meanings are different. And again, ChatGPT and other LLMs have special models that can create these vector embeddings to embed the meaning. Then we store these vectors in special vector databases, which are available by a lot of different companies. So we store all our different pages and smaller sections of our pages as vectors in such a vector database. And then when a user sends a new chat message like, "What is your TikTok link?" we turn this text into a vector embedding as well, and then we do a similarity search. A similarity search will try to find the vector in our database that's closest to this text, or multiple ones usually. In this case, this would be our TikTok section here. Yeah, and this is the whole idea. So now what we have to do is we have to take our single pages, we split them up into smaller chunks, we create vector embeddings of these chunks and store them in a vector database. And then we do a similarity search when we send a new chat message. And Langchain is not necessary to achieve this. In fact, in my other AI tutorial, we also do a vector similarity search, but without Langchain. But again, Langchain makes a lot of this stuff easier when our use case becomes more complicated. So let's go back into our project. I want to generate all these vectors for all our pages at compile time, so that when we build and deploy our website, we always have the latest information available. So what we do is we create a little script for this, but this script should work from the command line. So we put it outside of our Next.js project here in the root folder. We create a new file. First we create a folder called scripts, and then a file called generate.ts. Just make sure you don't put this into the src folder. This has to be put outside because we want to execute this from the command line. For this we set up a new command in the package.json up here in the scripts section. Below build we put another script called generate. The name is up to you, but this name makes sense. And if the generate script was a normal JavaScript file, then we would call node scripts/generate.js. But since this is a TypeScript file, we can't execute it like this. TypeScript is not automatically converted into JavaScript because this is outside of our Next.js project folder. So this is not handled by Next.js, we have to handle this ourselves. This is what we installed TS node for earlier, down here, to run this. So up here we execute npx ts-node and then ./scripts/generate.ts. This allows us to execute this TypeScript file. So from the command line we can run npm run generate to execute the script now, which of course right now does nothing. But when we compile the project with npm run build, I also want to execute this run script to generate all these embeddings. So we change this up here. At the start we call npm run generate and then 2 ampersand signs and then next build. So we save this. Now every time we run npm run build, we first run our generate script. So now let's put some life in here. So in here we create an async function called generate embeddings. And then below it, we immediately call this function so that when we run this file, this function gets executed. Then in here, we create a const loader and assign this to a new directory loader, which is an import from Langchain. Parentheses. As I explained, Langchain provides different file loaders. Now the other tutorials and code examples I checked often used this web loader to load the page from a URL. The problem with this approach, of course, is that our page needs to be available on a URL, so we can't run this at compile time, and also we have to handle each page one by one manually, basically. But this is not what I want. I don't want to handle each page one by one. I want our generate script to index all pages at compile time. This is why we will load them from the file system instead. And we can achieve this by just loading all our page.tsx files directly from the directory. And that's what we do here. So the first argument to the directory loader is the directory where we want to load this from, which is src/app/ as a string. And then we pass this block of curly braces as the second argument. In here we define how we want to handle different file extensions. We only care about tsx files, so we pass .tsx as a string, colon, and then this arrow function which gets passed the file path. And then we decide which file loader we want to use to load tsx files. I want to load them as strings, so we pass a new TextLoader, which creates this import here, and to it we simply pass the path. So this will load this tsx file as a string. And there's also a third argument, which is this recursive boolean. This decides if we load nested folders, and we want to pass true because we might have nested routes, which we also want to load. Okay, now we have our page files as strings, and now we want to split them up into smaller chunks. But first we have to filter our files because those are all tsx files, but we only care about page.tsx. Unfortunately, we can't put page.tsx up here. This only takes the file extension, but we can filter them manually. If you have non-page tsx files, so normal React components that also contain important information, then you can skip this filter step and just load all of them. But usually the pages contain the information we care about and the components just contain React code. And of course, if there are other file types you want to load and index, then add them up here after tsx. Okay, so below we create a const docs and we call await loader.load, which loads these files. As I explained, we want to filter these documents to only get the pages, so we put this part here into parentheses, because then we can append .filter on the result. Here we get past each doc, and we only want to keep the page.tsx files. So here we write doc.metadata.source, which contains the file name. So this is a string. Again, we don't get auto-completion because this is of type any, but this is a string. So we append ends with, make sure the spelling is correct, page.tsx. So we only want the page.tsx files. Okay, so now we have all the content of our page.tsx files in our project in string format. The next step is to split them up into smaller chunks, as I explained. The only problem is there is no text splitter in Langchain that can handle React code. This is a bit awkward because we only care about the relevant information here, which is basically this stuff, right? However, Langchain has an HTML splitter that can handle these tags here. The benefit is that it will keep these tags intact, so it will, for example, not split up a paragraph right in the middle, which we don't want. We want this whole paragraph in one document, and the HTML splitter can achieve this. Now, this is an HTML splitter and not a TSX splitter, so it doesn't know what to do with all of this stuff here. And I had to experiment with this a lot, but I figured out that if we remove the import statements, which we don't need, and also all these class names, because they are just clutter, they are not information. Then the HTML splitter is able to handle the rest, because TSX or JSX code is very similar to HTML. It's not quite the same because it also contains JavaScript, but it's similar enough that the HTML splitter can split this up properly. So to summarize, what we want to do is we want to remove these import statements from the string, and we want to remove all the class names. And then whatever is left, we give to the HTML splitter to get smaller documents. So let's do this. We want to do this for each document that we load, for each page. So below filter, we append .map. Again, we take each document. And we can also set the return type here so that we get auto-completion. So we surround this argument in the error function with parentheses, colon, document interface. Looks like we have to import this manually. It's an import from at Langchain /core/documents, and in here is the document interface. And such a document basically has two values. It has the page content, which is the string with all the TSX code, and metadata, which contains, for example, the source of this file. Actually, for now, let's comment out this map call and let's log these documents to the console so that we can see their contents. So we console log docs, we save this, we open a new command line window. You can also stop npm run dev or open a new command line. And then we want to npm run generate, which is our new script that we set up. Alright, there's still one thing we have to change. We have to go into our tsconfig file, and here at the bottom we add a comma, and we have to add this tsnode field, curly braces. Here we pass compiler options as a string because this is a JSON file. Again, curly braces, and here we set a module to common.js. I think this has to be lowercase. I'm not sure. This just changes how a tsnode executes these scripts. So after we saved this, our script should now work. npm run generate again. Yeah, and there is our document. So this is the JSX code of one of our pages. And at the bottom, we see the metadata, which contains the source of this file. So this is the social page, and this is the string content. Now our chatbot later should be able to provide a link to the page it's taking information from. So I want the URL to be part of the metadata, and we can infer the URL from the file source, because the folder structure reflects the URL, right? For example, this file here is on the /social page. So let's go back into our generate file. We uncomment the map call, and then we want to change these documents. So we add a pair of curly braces here. As I explained, we want to generate the page URL from this source path. So in the map call, we create a const URL equals, then we take .metadata.source, and I put these calls into separate lines just for organization. We call .replace. Again, we don't get auto-completion because this is of type any, but this is a string. So notice that I didn't put a semicolon here. This replace call still belongs to this metadata source. Parentheses, then we pass a regex, /, 2 backward slashes, again one / g, comma, and then a / as a string as the second argument. What this does is it takes all these 2 backward slashes that we have in the path and it replaces them for /. I don't know why file paths have this weird structure, but we need / for the URL. This is what we do here. Next we call .split and make sure all of this is spelled correctly, including the regex, because we don't have auto-completion here. And then we want to split the path right here, because everything before social is not part of the URL. So we want to split at src/app and only get this part. And then we also want to remove the page.tsx. We only want to have /social or whatever the path to this page is. So to split, we pass a string /src/app, no second slash at the end. And then we want to access the array at index 1. So .split turns this string into an array with two strings in there. The first string is whatever is before the src app, and the second string is what is behind it. We want to throw away the part before social and only keep the second part, so we access the array at the index 1, the second element. Then we want to split it again to get rid of the page.tsx. But I want this to work even if it's a JSX file, so instead of /page.tsx, we just pass /page. So if the page is a JSX file, this will work as well, even though you shouldn't write JavaScript if you are not a lunatic. Then we access this newly generated array at the index 0, because now we want the first element, the /social. So this will take every page in our project and turn it into a string that looks like this, /social or /privacy. And this should also work for nested routes like /user/profile or whatever, except for the front page. The front page will just be an empty string. So we have to handle this case. So we add two vertical bars here. If the generated URL is empty, which is the case for the front page, just because we stripped away all the text in there, then we want to set this to just /, which is the relative URL to the front page. Okay, cool. Let's see if this works. So still inside the map call, we return a new document. We should get autocompletion here because we set the type here. For the page content, for now we just pass doc.pageContent, the original content. And for the metadata, we pass a new object which contains the URL. So we throw away the source because we don't care about it. Let's save this and try this out. So again, we execute npm run generate. And now our new documents, contain the relative URL to this page, which we can later pass to our language model. This is the front page. And the other pages are generated as well. Nice. But we are not done yet, because as I explained, we also want to strip away all the import statements and the class name to remove the clutter, because there's no point in sending these class names to ChatGPT. It doesn't contain any actually useful information. So let's go back into our map call. Before we return our new document, we want to modify the page content. So we create a const, let's call it page content trimmed equals doc.pageContent, and then we call a bunch of replace functions and .trim at the end. Now I didn't want to type this out by hand. You have to pause the video and type this out, but you have to make sure to spell this exactly like I did. So here are empty spaces in these regexes. Pay attention to this, or go in the video description and copy it from the final project. But we need these replace functions, and I have comments next to them that explain what they do. So the first one removes all the import statements, the second one removes all the class names, no matter if they have double quotes, single quotes, or are curly brace expressions. This should work for all of them. And then we also remove empty lines. And at the end we trim all the white spaces from the beginning and from the end of the string. And then we get this page content trimmed, which we want to put into our new document. So let's save this and try this out again. Again, npm run generate. And now we have our trimmed files. So as you can see, the import statements are gone and all the class names are gone. We still have our HTML tags and our metadata, but this is fine because ChatGPT is smart enough to understand that this is just metadata, and it's smart enough to know that we don't care about these HTML tags. It will actually find the relevant information inside these tags. Now actually these HTML tags will even help ChatGPT because they provide metadata. This way ChatGPT knows that this is the headline, for example, so it's more important than the rest. And sometimes these HTML tags also contain important information, right? For example, the link tags have the href with the actual link. So ChatGPT will be able to read these links, or the alt prop of an image. So keeping in some of this HTML code is actually quite useful. And now, as I explained, we want to split up these large documents into smaller chunks because these pages can get big and we don't want to send huge pages to ChatGPT. And we can do this in just 2 extra lines of code. So below our docs, which are the full pages, we create a const splitter. We assign this to a RecursiveCharacterTextSplitter with an uppercase R, dot from language. And of course, this is a Langchain class. And here we can pass HTML. Because again, JSX is very similar to HTML, especially now after we remove the import statements and the class names. Then we have to run this. So we create a const split docs and call await splitter.splitDocuments and pass our original documents to it. And then let's log these split docs to the console. So let's save this and try this out again. So npm run generate. Now we should get smaller documents, but only for large pages. If the page is small, it will be generated as a single document. But as you can see, we already have multiple social chunks with smaller pieces of text in there. And as you can see, it keeps these paragraph tags together. This is what we achieve with this HTML splitter. We avoid that we split the text in the middle of a tag, because usually a tag contains one relevant piece of information, and we want to keep these tags together. So we have always complete HTML tags. Now it's not always perfect. As you can see here, for example, the h2 is in a different document than the text it actually belongs to. But this is completely fine because first of all, we have the relative URL in here. So ChatGPT always knows which page this piece of information belongs to. And later we will also search for multiple documents at once with our similarity search. So we don't need to send a single document to ChatGPT. You usually want to send multiple documents that belong together. So yeah, I tried this out and it worked quite nicely. This is why I came to this solution with the DirectoryLoader and the HTML splitter. And now the next step is to store these little documents in a vector database so that we can do a similarity search later. And then we are really close to creating a really nice chatbot. So let's set up our vector database next. Okay, as our vector database, we will use AstraDB by DataStax, where we can store our vector embeddings and do a similarity search. And they also have a free tier, so go to datastax.com. I will also put a link into the video description and create a free account. I trust that you are smart enough to create an account here all by yourself. And then when you are in the dashboard, we want to create a new database, a serverless vector database. We have to give it a name. Again, I'm going to call it Next.js Langchain Portfolio. The name is up to you. And the provider also doesn't really matter. I keep the default setting. And for the region, I pick US East 1. Create database. This will take a moment. We wait until this has finished initializing. Now, while this is loading, we can actually already prepare our environment variables. So we go into our env.local file, and here we need 3 new environment variables. Astra _db _endpoint. Let's keep it empty for now and duplicate this 2 times. The second one is AstraDB application token. And the third one is AstraDB collection. We can already set the collection. We will call this embeddings. This is just the collection name where we store our vector embeddings. And we will get the endpoint URL and the token from our database here once this has finished initializing. Okay, it's finished. And here we can copy our API endpoint. Maybe the backend looks a bit different in the future, but somewhere here should be this HTTPS endpoint. And we want to paste it here into this endpoint variable. And then we want to generate a token, which we also copy into our project right here, the application token. So it should start with this piece of text probably, but maybe in the future this looks different. Anyway, we want to have them in our environment variables. This now allows us to access our database, and let's create a new file where we set up our Astra database connection. I want to put this into the lib folder, which we already have. Right click on lib, new file, AstraDB.ts. And Langchain actually has an AstraDB integration, which makes it easy to connect AstraDB with our remaining Langchain code. First of all, we need our environment variables here. I want to store them in variables. Const endpoint equals process.env. Let's copy the name. AstraDB endpoint. And if this doesn't have a value, we fall back to an empty string. The same for the token, process.env, application token with this fallback value. And lastly, const collection equals process.env dot AstraDB collection, empty string. Then below I want to throw an error if these values are actually empty. If we forgot to set the environment variables, it's good to throw an error as early as possible. So we check if exclamation mark token or exclamation mark endpoint or exclamation mark collection. If one of these values is missing, we want to throw a new error with an error message that says, please set AstraDB endpoint, AstraDB application token, AstraDB collection, environment variables. This error message is up to you. You can also just write environment variables missing or whatever. But yeah, this way we make sure that when we load this module and one of these variables is missing, we immediately get an error. Below we create an async function and export it, and we call it getVectorStore. No arguments. And as I explained, AstraDB has an integration for Langchain. So here we want to return an AstraDB vector store. Looks like we have to import this manually. Import curly braces from @Langchain /community/vector stores. Okay, I'm confused why I don't get auto completion. Let's see if this works. AstraDB. Yeah, it works. Just didn't get autocomplete for some reason. And in here is the AstraDB vector store, which we want to call down here. And on it we call from existing index. And to it we pass another Langchain class, which is new OpenAI embeddings, parentheses. This is responsible for making another request to the OpenAI API, but this time not to get a chat completion, this time to create these vector embeddings from our documents. Here we want to set the model name, because the default model name is an older one. They just came out with a completely new model, which is cheaper and also faster and better, which is called text-embedding 3 small. Make sure to spell this correctly. Again, this is a new model that just came out recently, which is better than the default model. I assume that this will eventually be the default model of this object here, but right now it isn't. So we have to set this manually. And again, this OpenAI embeddings is an abstraction provided by Langchain. If you want to see how to create these vector embeddings without Langchain by using OpenAI's TypeScript library directly, We do this in my other AI tutorial, the note-taking app one. Okay, then after a comma as the second argument, we pass some configuration in curly braces. Here we have to pass our token, the endpoint where we want to store these vector embeddings, the collection where we want to store it in, and then these collection options, to which we pass another pair of curly braces. Then vector colon curly braces. In here we set the dimensions to 1536. This is what I explained earlier. The dimensions decide how many numbers are in these vector embeddings arrays. The more dimensions, the more information we basically can store about a text. How did I came up with this number? Well, this is the number of dimensions this OpenAI model here generates. So I found this in the documentation of OpenAI. This is the number we have to pass here. We could also pass a smaller number, but then we would basically lose information. So we pass 1536. And as the second value, we pass metric colon cosine. This sounds very complicated, but this is just the algorithm how these dimensions are compared later. And cosine is the default that we want to use with OpenAI embeddings. Okay, cool. Now we have this vector store object, which we can use to store our documents in AstraDB. And we can also later use it to retrieve these documents and run a similarity search with our chat messages. The only problem is this AstraDB abstraction by Langchain doesn't provide a way to delete all documents in our collection at once. But before we create new vector embeddings, I want to delete all the existing documents and clear the whole collection, basically. The AstraDB abstraction doesn't provide a function to do this, so we have to use the native AstraDB library for this one use case. So below we export another async function, which we call get embeddings collection, where we don't use Langchain's AstraDB wrapper. We use AstraDB's own library to access the database because this has a delete many function. So here we return a new AstraDB, which is an import from DataStax's AstraDB TS, which we installed in the beginning. Parentheses, here again we have to pass the token and the endpoint, which we get from our environment variables. And then we want to access our collection. So later we can access the database through this function, and then we can delete all our documents. Let's save this file. Just one mistake here, I made a typo. This should be endpoint, right? Otherwise this variable will be empty. And now we go into our generate script. And here we now want to store these documents in our vector database. So what we do is at the very top of this function, we create a const vector store and we call await and then our get vector store function. Below, we want to delete all the existing vectors that we already have in our database. So we call await get embeddings collection. We wrap this into parentheses, and on the result we call delete many, to which we pass parentheses and an empty pair of curly braces. So we don't pass a filter to it because we want to delete all documents in our collection. Now it's important that we first call get a vector store and then delete many, because get a vector store internally initializes this collection if it doesn't already exist. Now you might be wondering, wait, isn't it expensive to always delete all documents and create all vector embeddings from scratch? But the thing is, these embedding models are extremely cheap. As you can see, embedding small, the one we use, costs a fraction of a cent for 1000 tokens, and 1000 tokens is about 750 words. So even if your page has tens of thousands of words on it, it will still cost less than 1 cent to generate the embeddings for the whole page. So it's really not worth the hassle trying to implement an algorithm that only creates embeddings for files that have changed, because these embedding models are extremely cheap. This only matters if you have a huge website, like we are talking about thousands and thousands or even tens of thousands of pages before this adds up to any significant amount. Now Langchain actually has a class that helps managing these changes and only creating vectors for files that have changed. But again, it's not really worth going through the hassle of implementing this for a page that's not huge. So yeah, every time we compile the project, we clear our embeddings collection and create new embeddings for all pages from scratch. This way we make sure that our chatbot always has the latest information available. Okay, just one more step. At the bottom, after we split our documents, instead of logging them to the console, we call await vectorstore.addDocuments and pass the split docs. And Langchain takes care of all the remaining steps. So this will automatically send our documents to OpenAI's embedding API because we passed this OpenAI embeddings object here. It will request these vector embeddings, and after it gets them back, it will store them in our AstraDB. Before we can try this out, one more thing. Since this generate script is not part of our Next.js app, the environment variables will not be set by default. They will be empty. This is why we installed the .env library in the beginning. We have to set up these environment variables ourselves. We do this at the very top, and it's important that you do this as the first import. It must not come after the imports here where we call our AstraDB functions, because in here we use the environment variables and we have to set them before we import these functions. So at the very top of our file, we import .env from .env, and right below we call .env.config, parentheses, curly braces, and here we set the path to .env.local, because by default this looks for a .env file and not .env.local, but this is where our environment variables are, so we have to configure the path here. And again, it's important that you call .config before we import our AstraDB functions. And you have to pay special attention when you reformat your code, because this might automatically put us below these imports and then it won't work anymore. So we have to keep them at the top. Now, I found a little trick. When we put a comment down here and press the reformat shortcut, then they stay at the top for some reason. So maybe let's put a comment here that says configure.env before other imports. There's one more thing we have to change. This add before /lib points to our src folder. However, this won't work in our script because again, it's not part of our Next.js project. So this import alias is not set up. Instead, we have to change this to a relative import with /src/lib. Then it should work. So if something doesn't work for you, compare your code with my code and make sure all the imports and all the code is correct. Then let's save this file. And then let's run this generate script again. Okay, I still have the same typo in here. It should be endpoint, not endpoint. Let's try this again. Yeah, and this is the output. It seems to have worked. You can ignore these unknown file types. This is coming from the DirectoryLoader. It finds these other files, but we don't handle them, we ignore them. And now these documents should be stored in AstraDB. So let's refresh this and then take a look into the Data Explorer. Yeah, continue. Don't show me this again. And here we now have our embeddings collection, and those are our vector embeddings. Isn't this cool? So we can open each of them. We see the text that they contain, the way we split them up earlier. We have our metadata, the URL, and then we have this vector, which is this huge array of numbers I was talking about. Those are 1536 numbers or dimensions, and they contain the meaning of this text in form of a number. And now when we send a message to our chatbot, we want to find the relevant vectors in our database that have a similar meaning, pass them to our chatbot, which then reads the text in there and answers our question based on this information. So let's go back into our project. Okay, we want to open our chat route again and make some changes to our chain here. So we want to remove this sarcasm system prompt and want to put the real prompt in here. So this will say you are a chatbot for a personal portfolio website. Again, this is how we give the OpenAI AI instructions. We just write plain text and describe how it should behave. Let's also say you impersonate the website's owner, but you can change this prompt and play around with it until you have the behavior that you want. Then I want to put a string over multiple lines just for organization. So what we do is we write a plus here at the end and a space at the end of the string and add another line. This will all be appended into one line. I just want to have some organization in here. And I don't like these backtick strings because then we have to put the text all the way to the left side here of our code, which makes it awkward to look at. Answer the user's questions based on the below context, and the context will contain the documents that we fetched from our vector store. Again, space plus and another string. Whenever it makes sense, provide links to pages that contain more information about the topic from the given context. You just want to be as exact as possible in your instructions. And one more text I want to append. Format your messages in markdown format. Okay, so this is the prompt and this dot should be in here, not outside of the string. Then I want to add 2 empty lines, which we can do with \n plus, and then lastly we want to put the context in here. Context colon, again a new line, and then we add this variable placeholder again without the $sign, just the curly braces, and in here we write context. Just make sure that all the pluses are here so that this is actually one string that we pass to our LLM, and the context will later be replaced by the documents that we fetch from our vector store. And to add the context here, we remove this chain down here, and instead we create a const combine docs chain. Then we call await, and then we have this createstuffDocumentsChain function from Langchain, to which we pass a pair of curly braces. In here we define the LLM we want to use, which is our OpenAI chat model, and the second argument is the prompt we created up here. This createstuffDocumentsChain is simply responsible for taking documents and putting them into this context field. This is all it does. Now we could invoke this chain and pass the documents that we want to have as the context manually, but instead we want to do this automatically from the user input. For this we use a retriever. So below the combine docs chain, and I know that this is very complicated, but this is how Langchain works, and when you play around with this for a while, you start to wrap your head around it. So below we create a const retriever. We call await get vector store, which is the function we created earlier in our AstraDB file. We wrap this into parentheses and then call sRetriever on it, which gets our vector store, but this time not to put documents in there, but to retrieve documents. Then below we create a const RecursiveCharacterTextSplitter. We call await createRetrievalChain, and to it we pass our combined docs chain from up here, and the second argument is the retriever. Yeah, and this up here should be called combined docs chain and not chains. So now this error here disappeared, and then we simply invoke our retrieval chain down here, and the rest stays the same. Now to recap, what this does is the retrieval chain will take this user input here, it will turn it into a vector. This all happens under the hood. Then it will do a similarity search in our AstraDB vector store and find documents that are similar to the user input. It will then pass all these documents to the createstuffDocumentsChain, which takes them and puts them into the context field of our prompt. And in the end, what we get is this prompt with all the relevant documents in the context and our new user question. We send this to ChatGPT and it generates a new AI answer. A lot of this is hidden from us, but there's actually a cool trick we can use to see the generated texts and prompts. We go into our ChatOpenAI model, and here we set verbose to true, which logs a lot of stuff to the console. Let's save this and try this out. We already generated the vector embeddings, right? If you didn't, run npm run generate in the console. Let's refresh the page. And now we should be able to ask our bot about information on the website. And it shouldn't matter where this information is located. Via the vector search, it should always find the relevant piece, the relevant document. So maybe let's ask about my channel URL. What's your YouTube channel URL? Let's see. Thinking. My YouTube channel URL is here. And this link is correct. As you can see at the bottom, coding and flow. Awesome. It found this information on our website. The only thing that doesn't work right now is for one caching, but also asking follow-up questions. Because right now we only send the last user message to our prompt. Which means that if I ask a follow-up question like, where did you find this information? The chatbot will probably not understand that this new question is still related to this first question. So it should answer something that doesn't make much sense. Let's see. Yeah, this is exactly what I was talking about. It talks about the privacy policy, but my channel link is not on the privacy policy. Because the AI doesn't know that this question still belongs to the first one, we will change this next. And we will also summarize these multiple questions into a new search query to find more exact results in our vector store. And let's also take a look in the console because we added the verbose logging, right? So in here we now find a bunch of text. For example, here we can see the whole generated prompt. You are a chatbot, blah, blah, blah. Then we have the context. And then we have the content of the pages that it found. Now there's still something missing here. This is only the content of the page, but the URL that we store in the metadata is not part of the prompt. So we want to put this in here as well. And I think by default, this searches for 4 documents in the vector store. You can customize this in the retriever function here. As retriever, you can pass a number which defines how many documents this should search for. If you find that not all the relevant information is in the context window, you can increase this number to, I don't know, 10 or whatever. But keep in mind that the more text you send to ChatGPT, the costlier the request becomes. And when you send too much text in there, it can also happen that you exceed the token limit and you don't even get a response back, or your text is just cut off. In order to get the URL into our documents before we pass them into the context window, we go to our createstuffDocumentsChain. Here we can pass a document prompt to which we use this generic prompt template. But I think the import is wrong. Let's see. Yeah, there is no import at all. We import this up here from /core/prompts. After the chat prompt template, we have this generic prompt template. This just decides how this chain takes each document from our vector store and puts it into this context window. So how each document is formatted. To this we simply pass a string. Now the default value looks basically like this. Page, content, and that's it. So it just puts the page content of the document in here. But I also want to put the page URL in there so that the language model can see it and work with it. So we change this template. We write page URL. Here we put URL in curly braces. This has to be called URL because this is the name we gave this metadata field over here, right? URL. It has to have the exact same name because this value will automatically be put in there from the metadata. Then we make 2 line breaks with \n. Then page content colon. Let's add another line break behind it. And here we put page_content, which is the page text itself. And this up here has to be a prompt template.from template, like this. Then we also override the document separator, which defines how these different document prompts are separated. By default, this is just an empty line, but since we now have a bunch of text in here, I want to make the separation more clear. So we add a line break, and then just a bunch of dashes, add another line break with \n, and in the front here as well. So now each document will be formatted in this way, and each document will be separated with these dashes, and the LLM is smart enough to understand that these are separate documents. In this regard, it's almost like a human, like you can send data to it the same way you would format it for a human, and it will understand it, probably. Let's save this and try this again. So again, I want to ask a random question, and then I want to look into the console and see the output here. But let me first clear the terminal, send a new question, and then the generated prompt should look a little bit different. You are a chatbot, then we have our context, and as you can see, we have the page URL/social, a few line breaks, and then the page content. Then we have the separator, next page URL, and so on. And the benefit of this is that our language model now knows the URL where this information is on. We can't send a follow-up question yet, but let's just send a new message. On what page can I find out more about you, maybe? This should point us to /about, ideally. Let's see. It should now have the relevant URL in its information, and in fact, it found the /about page. Isn't this cool? And we can even click this link and we get to this page. Amazing. Okay, so the next step is to implement these follow-up questions. So to pass our chat history to Langchain, we first have to turn it into a format that Langchain can understand. So below const messages, let's create a const chat history. We take our messages. Then we want to slice this. To slice, we pass 0, -1, which removes the last message from this array, because this is already in this current user message. Then we call .map, 2 pairs of parentheses. In here we get this message, which we also want to type with this message type from the Vercel AI SDK. So this import statement is up here. But let's rename this import just to make our code more clear. So after message in the import statement, we write as Vercel chat message. And then we use this name down here just to make it a bit more explicit that this belongs to the Vercel AI SDK and not to Langchain. And then we want to map this into a format that Langchain understands. So we check if m.role, so the role of this message is user, then we want to return a new human message, which now is a class from Langchain, and to this we pass m.content. And if it's not sent by the user, then we want to return a new AI message, to which we also pass m.content. This here, of course, should be messages, and then the import statement of these message objects is wrong again. If we import this from Langchain schema, we will get a warning message because this is deprecated and they will be removed in the future. Instead, we should import this from @langchain/core/messages. In there we can find these same types. Okay, now we have our chat history, and the first thing I want to do is I want to turn this chat history into a search query that we can then use to find the relevant vector embeddings. Now we could also just take the whole chat history as it is, turn it into a vector and use it for our search, but this will be inexact. Because imagine we talk about one topic, we get an answer, and then we talk about a completely different topic. If we turn this whole history into a vector embedding, then it will have two completely different meanings in the same vector, which can work okay, but it's not very exact. And we retrieve documents that we don't actually need. Because if we changed topics, then we only care about the new topic, not about the old one. And we can use ChatGPT to rephrase a new search query. So what we do is we go below our chat model, but above our first prompt here. We create a const rephrase prompt. Again, we create it from a chat prompt template, from messages, parentheses, square brackets. Then first we pass a new messages placeholder, to which we pass a string that says chat underscore history. Looks like auto import didn't work. We want to import this here from Langchain core prompts up here. Messages placeholder. This takes our whole chat history that contains human messages and AI messages, and it formats them into separate message objects that we can put into our array here. Okay. The next element is the new user message again. So this line that we already have down here, we copy it, paste it here as well. And then a third one is another user message that contains the instructions how ChatGPT should rephrase our chat history. So again, we write this as plain text. Given the above conversation, which is our chat history and our new user message, generate a search query to look up in order to get information relevant to the current question. Again, how exactly you phrase this prompt is up to experimentation. This worked quite nicely for me. Again, I put an empty space in here. I want to append some more string in the next line. Don't leave out any relevant keywords. I found that this makes it more exact. Only return the query and no other text. This way we avoid that it responds with something like, here is your new search query, colon, blah, blah, blah. We only want the query and nothing else, because this is what we want to search for. Okay, and below we want to execute this rephrase prompt. For this we create a const HistoryAwareRetrieverChain, and then we await and call this function createHistoryAwareRetrieverChain, which is another import from Langchain. This chain is responsible for taking the chat history and putting it into this prompt here. So we call this parentheses, curly braces. Again, we have to pass the language model, which is our chat model, the retriever, which fetches the necessary documents from the vector store, and our rephrase prompt. And we initialize the retriever down here. We have to move this up. So we have it available here. Let's put it below the chat model for organization. So now we send our chat history to this rephrase step, where ChatGPT rephrases the history into a search query. We still want to pass the same chat history to the actual prompt, to the chat, because ChatGPT uses this then to generate an appropriate answer. So we go here into our chat prompt template with the final prompt that contains the context. And here, before we send the user message, we also add the chat history in form of a messages placeholder. Okay, then down here in the retrieval chain, instead of the normal retriever, we now pass our HistoryAwareRetrieverChain as the retriever, because this now fetches the documents depending on the chat history. Again, I know this is super complex, but this is how Langchain is set up. And finally, we have to pass the chat history down here where we invoke this chain. We actually get auto-completion, this chat history field, for which we pass our chat history variable. So now our chat history should be passed to the LLM and we should be able to ask follow-up questions. So let's ask, what are your hobbies? And then where did you find this information? Now this is interesting. What the hell is this text here? This is actually our rephrasing prompt that we use to generate our search query. This is streamed into our chat because we run it with the same AI model that has our stream callback here. And I wanted to show you this on purpose because this way we can see the new question it generates. So it took my original question, what are your hobbies, and my follow-up question, and it turned it into the search query, hobbies of an AI programming assistant. Now it's not perfect, but you can fine-tune this prompt here. Let's also take a look into the console. If we can find this rephrase prompt somewhere here. This is our final prompt. Given the above conversation, generate a search query to look up. And here is the conversation, right? Where did you find this information? The first answer and our original question. And it turns this into a new search query. But of course we don't want this to be streamed here, we want the actual answer. We can fix this problem by creating a second chat model up here. So let's duplicate this line, just copy paste it, and let's call this one rephrasing model. And here we want to remove the callbacks, and this also doesn't need streaming. Because we are not streaming this into the chat, the user actually never sees this. We can still keep the both true for logging, and then in our history AwareRetrieverChain, we don't use our chat model, we use the rephrasing model, because now this will not be streamed into our final chat. So let's try this again. Let's refresh our page. Again, I'm gonna ask, what are your hobbies? Where did you find this information? And it should provide the appropriate link. You can find this information on my About page. And now we have an amazing chatbot that is aware of the chat history and can find the relevant information. This is so cool. The only step left is we want to cache the responses in Redis, because then if we have a lot of visitors on our web page and they ask the same questions, then we can just return the cache response and we don't have to make a request to OpenAI, which also saves us money. And in the end, we will also deploy this project to Vercel, to a real HTTPS domain, so that you can send your project to other people. The easiest way to activate a cache is to just go to our chat model here and set cache to true. This activates the in-memory cache by default. Let's try this out. Let's refresh the page. Ask, what are your hobbies? The first response will be streamed in from ChatGPT. Now I clear the chat. I don't refresh the page because this cache is only stored in memory. I just clear the cache, ask the same question again. And there is this bug I was talking about. For some reason, this button sometimes doesn't enable. So I guess we have to go into our AI chat box to the disabled state down here. And we have to remove the is loading because it seems that sometimes this doesn't reset properly. I'm not sure why, and I'm not sure how to fix this right now, but let's just remove this, which also means that the page was refreshed, so we have to run our query again. So again, this will be streamed in because this cache is only stored in memory. Then we clear the chat, ask the same question again, and now it will come from the memory cache. As you can see, it didn't stream this time. It popped up immediately from our cache. But Next.js uses serverless functions, so this memory cache will not stay active between different users, which means that we have to cache these responses somewhere else. In a database, and this database should also be really fast, and this is something you usually want to use Redis for, which is a very fast in-memory database, but this runs on an external server. We can use this for free. Again, we create an account here, go to upstash.com, create an account, and then we see us on the other side. This is the backend, looks pretty simple, and here we want to set up a new Redis database. So create database, Next.js, Langchain, portfolio, regional, Virginia, and we activate this stuff, I guess. Create. And setting this up is pretty simple. We get some environment variables that we need. Where are they again? Yeah, here, REST API, these ones. .env. We copy them into our project. In the env local file. These are our Reddit connection keys. Then we go back into the route.ts file. And here at the top, we create a const cache, for which again we have a wrapper by Langchain, new Upstash Redis cache. And this is the benefit of Langchain. It has integrations and wrappers for all these different tools, so we don't have to set them up manually. The price we pay is this extra layer of abstraction, which can sometimes be complicated. But overall, I think it helps more than trying to do this without Langchain. In here we have to pass a Redis client, for which we pass Redis with an uppercase R, which is an import from @upstash/Redis. And then we call from env, which automatically reads the environment variables that we just copied to create a Redis client. And then we simply pass this cache here, and that's it. And let's also cache the rephrasing model as well, so that we can ask follow-up questions. So we pass the cache to both our AI models. Let's save this and try this out. Refresh the page. Ask the same question, what are your hobbies? Now it should be streamed the first time. Follow-up question, where did you find this information? I just have to make sure that the next time I spell the question the exact same way again. So I copy this, send this message. Again, this will be streamed in. But now if we refresh the page and ask the exact same questions again, it should provide the answers from the cache. Let's try this out. What are your hobbies with the same spelling? And it got it from the cache. As you saw, there was no streaming. The answer just popped in. Follow-up question should work the same. And it does. So just like this, very easy, we set up a cache for our AI. We can also take a look into our Redis database here. Let's see, where is our data? Somewhere here should be a browser. Here, data browser. And we have 3 entries. 2 of them contain the responses that we saw. Here, the information about my hobbies. And this one is the rephrasing prompt. Source of information on hobbies. And if you're wondering where is the prompt that we send to the AI as the user, where is this stored? This is actually stored in this number here. This is the prompt hashed. And it uses this hashed prompt as the key in the Redis database. And in here is the answer we got for this prompt. Okay, just one more thing. When we generate new vector embeddings, we also want to clear the cache because the information on our website might have changed. We do this in our generate script. At the very top, we simply want to clear our Redis database, which we do with await Redis, again import from Upstash Redis, from env.flushdb to clear it. We can also try this out. Maybe this time let's just build our project and see if this executes our generate script. So npm run build. It should first execute our generate script and then compile the project. Yeah, looks like this all worked. Our pages are also statically cached by default. We can run npm start to start this in production mode. And our Redis database should be empty again when we refresh this. Yeah, because we clear it when we create new vector embeddings. But of course, we can ask new questions to our AI. For example, what are your current side projects? Let me copy this question. And it lists my 2 projects at the moment. By the way, smartdiary.co is an AI app I'm currently working on as a side project. Would be happy if you check this out. But now let's refresh the page and ask the exact same question again, which should be coming from our cache. Yeah. Okay, so this all works really nicely. I think this is a super cool project that you can build to impress recruiters, or also, as I said earlier, build a smart documentation page. As the last step, I also want to deploy this project to Vercel to show you that this also all works in production. So as usual, the easiest way to deploy a Next.js project is to deploy it to Vercel, who are the creators of Next.js. We can log in at vercel.com, go into our dashboard, and here we can add a new project and can load a project directly from our GitHub repository. For this, you have to connect your GitHub repository to your Vercel account, which you can do in your account settings. And your project also needs to be on GitHub. You can do this directly in VS Code here in the source control sidebar. You can publish your project directly to GitHub. Doesn't matter if it's a public or a private repository. And then we want to import it here in Vercel. It automatically detects that this is a Next.js project. We have to copy our environment variables in here. For this, we go into our project again, env.local. We can copy all of them at once and just paste them into the first field. And it adds all of them like this. And then we deploy this project. And this will compile the project, which also means that this executes our generate script. So it creates new vector embeddings and it clears our cache. And after this has finished, we get some confetti and there's our website. And we can even open this on a real URL. You can share this URL with someone. You get this for free. All our pages still work and they are super fast. And our chatbot should work as well. Hi, who are you? I'm Florian, full stack developer, blah, blah, blah. Let's see if the cache still works. Copy this question, refresh the page, ask this again, and this time it comes from the cache. Perfect. Let's also test that it actually regenerates the vector embeddings. Let's go into our DataStax database once again. Let's open our collection here, Langchain portfolio, and our embeddings collection, and let's just delete this whole collection and see if it gets regenerated when we build our project. So now our collection is empty. Let's go to our Vercel account again, open our portfolio project, deployments. I just want to redeploy this, which compiles the project again. So redeploy. Again, this takes a minute or so. And in the process, it should create new vector embeddings. One thing I also want to point out, it's possible that this verbose setting in our clients makes the AI response a bit slower. I'm not sure, but it could be the case. Anyway, we can also look into the build output, where we find the call to our generate script. So this step should already be done. Let's look into our DataStax database, refresh this, and then we see our new embeddings. Perfect. Alright, I hope you enjoyed this tutorial. Please leave a like on this video if you did. Also subscribe to the channel for more Next.js tutorials in the future. Also, if you followed along with the whole tutorial and you deployed your project, I would be really happy if you would tag me on Twitter @codingandflow and send me the link to your portfolio website. Alright, and then we see us in the next tutorial. Happy coding, take care.